Emerging in 1970s as SQL and evolving within the IBM system are SQL now dominates as the go-to language for relational databases. It supports complex queries and diverse joins with popular databases like MySQL, PostgreSQL, and Oracle using it. Widely employed in the web development, mastering SQL can greatly benefit aspiring developers. The SQL developer earns around $98,000 per year. However, the additional cash compensation may range from $4,600 to $8,500. So, are you ready to get started with this amazing career? Check out postgraduate program in full stack web development by Simplilearn. With this amazing program, you will be benefited with Caltech CTME postgraduate certificate, receive up to 25 CEUs from Caltech CTME, attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs. By the end of this course, you will be skilled with Agile, Java, Hibernate and JPA, Spring Core 50, HTML5 and CSS3, AWS, JavaScript, and there is huge on the list. Expertise in the tools like Angular, CSS3, Docker, Git, HTML5, Jenkins, MongoDB, and MySQL will add value to your resume. So hurry up and enroll now. Find the complete course details from the link in the description box. Millions of learners are benefited with our courses. Listen to the success story in their own words.
Learning is growing, and we not only decided to grow together in life but learn and succeed together as well.
I successfully switched my career to full stack Java domain with a 15% salary hike.
And I was able to grab new opportunities in my current organization and also receive a 10% salary hike. Hey, I am Somjit Basu. I am a senior QA engineer at Encora Inc.
And I am Shomi and I work as a senior quality analyst at Doodleblue Innovations.
We started our upskilling journey together with Simplilearn, and certainly we made the right choice.
After our marriage, I had to relocate to Bangalore and take a year gap after working for 5 years. But I decided to restart my career again and make a switch to software domain. So I enrolled myself in full stack Java developer program from Simplilearn.
Seeing my wife's passion for learning every day inspired me to take up a course on Simplilearn as well. I've always been passionate about technology, and learning DevOps was always in my bucket list. When I saw Simplilearn's collaboration with Caltech CTME, I decided to take a course on PG DevOps.
After the course, I not only switched my career to full stack Java development with a 15% increment in the salary, but now also I can work from home since it's a software domain. And being the new mom, that's the best thing one could ask for, to spend time with little one during these early years.
For me, learning DevOps was fun and fulfilling at the same time. Earlier, I had to rely on others at work, but after upskilling myself, I single-handedly can set up the entire blueprint on my codebase alone and get the desired output. And because of that, I could grab new projects in my organization with a 10% salary hike.
We enrolled to upskill ourselves when we were expecting our first child. So upskilling journey with Simplilearn would be undoubtedly very special to both of us.
While doing the course, we did come across a lot of challenges due to the pregnancy, but my wife Shomi was a great inspiration for me as she was handling it all together, and she kept motivating and inspiring me all the way. Moreover, the recorded classes and the weekend class helped us maintain the balance between work and learning.
Apart from work, we love to spend time with our little one. Learning with Simplilearn was quite a fulfilling experience for both of us. We believe that growth doesn't happen overnight, rather it's a journey of several small steps, and upskilling is one of them.
So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here each row represents a record or a tuple. So you have the player ID, which is 103 here, the name of the player is Daniel, he is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records and do a lot of other tasks.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as Data Control Language (DCL), helps protect your database from unauthorized access. Who is a SQL developer? SQL developer is a person who is accountable in creating and managing huge data assets of a company. In other terms, SQL developer is a person who can develop SQL databases as well as write and test code. Let's understand this with the help of an example. Let's say we want to search a particular product on Amazon website, and Amazon has stored all its data about products in a database. Now we will write the product name in the search bar, and when we click on the search button, it will run a SQL query that fetches all the information about the product and displays us on the website. So this is the basic task done by a SQL developer. Now we will understand the responsibilities of a SQL developer. All databases have a structure and logic behind how data is stored and retrieved. A SQL developer designs the database accordingly for businesses, that is called database modeling. After the database is created and deployed, it's the SQL developer who is responsible for fixing the general issues of the database. SQL developer should be well versed with structured query language to create optimized SQL queries and refines the existing ones to extract information from the database. SQL developers run several diagnostic tests to keep a check on the server and the database. In order to understand how to organize companies' data, SQL developers must communicate with technical and non-technical persons from the business, and SQL developer also gathers client requirements and identifies the features that the database owners want. As data is an asset to a company, SQL developers backup and restore data for their clients. They also perform tasks like data management and data migration. That is, if a company has stored all its data on a local storage and now it wants its data to be stored in a cloud storage. So the safe transmission of the data from local storage to cloud storage is known as data migration, and that is done by the SQL developers. After knowing the responsibilities, now we should look for skill set required to be a good SQL developer. One should have a good knowledge of SQL commands, functions, joins and procedures. Let's have a look at few commands such as create, drop, alter and truncate. These commands come under data definition language. We also have insert, update and delete commands. These commands come under data manipulation language. We have grant and revoke commands. These commands come under data control language. We also have commit, rollback and save point commands. These come under transaction control language. These are the basic commands a SQL developer should be familiar with.
and a SQL developer may have a little command on any one programming language. You don't have to be expert in programming. All you need is how to interface between application and your database. For example, you are using MySQL and your web application is based on PHP. Then you should know how to connect your application to the database and how to issue queries, how to fetch results, and then how to display it to the users. One should have a good understanding of various database management systems such as MySQL, Microsoft Access, Oracle, PostgreSQL, DBase, FoxPro, SQLite, IBM DB2, LibreOffice Base, MariaDB, and Microsoft SQL Server. One should know integration of databases with data visualization software such as Power BI and Tableau, which helps businesses to make better decisions and give you an add-on as a SQL developer. One should develop critical thinking and problem-solving skills to create optimized queries. Now we'll see how a SQL developer is compensated in both United States and India. In the United States, SQL developers draw an average salary of $72,282 per annum. In India, the average salary of a SQL developer is Rs 4,49,532. Now we'll see how a person can become a good SQL developer. For that, one should have a good command on structured query language and know how to interact with database management system and can issue queries to get the desired result. Earning industry recognized SQL developer certifications such as Microsoft Certified Professional Developer MCPD or Oracle PL SQL Developer Certified Associate, which usually require a passing score on an exam. And it's important to accumulate as much practical experience as possible. Start by designing, creating, and querying small databases connected with your hobbies and interests. For example, your favorite music, videos, or your personal finances. This will enable you to gain experience, test your knowledge, and build your project portfolio, which will be highly beneficial when you start applying for your first full-time position. Now we will see some major companies recruiting SQL developers. First we have the multinational financial services corporation American Express, followed by the multinational professional services network Ernst & Young. We also have the messaging company WhatsApp. Then we have the e-commerce giant Amazon, as well as the technology and computer solutions company Dell. Finally, in our list of companies, we have the multinational technology company Google. So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and the relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database, which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram, starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent the relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. When a single element of an entity is associated with a single element of another entity, this is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2, and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2, and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit, and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp, and others. Then we have string data type, which includes char, this varchar, and text. Finally, we have binary data types, and binary data types have binary, var binary, and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division, and modulus. Then we have some logical operators like all, and, any, or, between, exists, and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to, or less than equal to, not less than, or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types and operators that we just learned.
In this session, we will learn how to install MySQL Workbench and then we will run some commands. Firstly, we will visit the official Oracle website, that is mysql.com, and now we'll move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission. Click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL server, MySQL shell and the MySQL workbench. Expand MySQL servers by double clicking on it. And choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL Workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you'll see the product configuration. Click next. Now we'll configure our SQL Server instance. Here we'll go with the default settings and click next. And under authentication, select use strong password encryption for authentication, which is recommended, and click on next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I will click on next. And here also we'll keep the default settings and click on next. Now to apply configuration, we will execute the process. Once all the configuration steps are complete, click finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL shell after clicking on finish. Now the shell and workbench has started. Now we will connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we'll reach the path where MySQL files are present. We'll go into this PC. local disk C, program files, MySQL, MySQL Server 8.0, bin. And now we'll copy this path. Now we'll open the command prompt and write a command cd space and paste the link and press enter. Now we'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started, and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL 80 and enter the password to connect to the local host. The MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. Show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database, and now in this database we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns underscore prive, component, db and much more.
Now let me now go ahead and open my MySQL Workbench. So in the search bar I'll search for MySQL Workbench. You can see I'm using the 8.0 version. I'll click on it, and here it says welcome to MySQL Workbench, and below under connections you can see I have already created a connection which says local instance. Then you have the root, the local host and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL Workbench looks like. Here we learn some of the basic SQL commands. So first let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases, 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon, and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country and country language. Now if you are to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database and I'll name it as SQL intro. So the command is create database and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL intro. If I scroll down, there you go, you can see the name here, SQL intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL intro database. So I'll use the command create table and then I'll give my table name, that is going to be employee_details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name, followed by the data type for this column. Since name is a text column, so I'll use varchar and I'll give a value of 25. So it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the char data type or character data type and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city and salary. For each of the columns we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp_details. If I run this, there you go. So under field you can see the column names, then you have the data types. Null represents if the table can accept null values or not, and these are basically empty. and we haven't set any default constraint. Alright, moving ahead. Now let's learn to add data to our table using the insert command. So on a notepad, I have already written my insert statement. So let me just copy it and then I'll explain it one by one. Alright. So if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values, I have passed in all the records. So first we have Jimmy, which is the name of the employee. Then we have 35, which basically represents the age. Then M means the gender or the sex. Then we have the date of join. Next we have the city to which the employee belongs to, and finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, there's Dwayne, Sarah and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the state of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case, you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that, I can write my select statement as select distinct. Then I'll give my column name, which is city, from my table name, that is emp details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin and New York. Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. In that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this, this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result, it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum, and since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this, this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary. So instead of sum, you can write the average function, which is avg. So this will give you the average salary from the column. salary. So you can see it here. This says average salary. Now if you want, you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age and the city column from my table, that is employee details. So this will result in displaying only the name, age and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender which is sex here, comma city from my table, that is employee details, where I'll give my column name, that is sex, is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case you can use the OR operator. Now the OR operator in SQL displays a record if any of the condition separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the city Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the OR operator, this time I'm going to use the in operator. So I'll delete this. After the where clause I'm going to write where city and use the in operator. Inside bracket I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from emp details where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000, and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here, who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table, where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like, for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on their gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary, as I'll give an alias name, let's say total salary, from my table name, that is employee details. Next I'm going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from emp underscore details and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of their salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India and I'll give an alias as total length. If I run it, You see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed at the rate 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it has converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that you can use a function that is called now. So this will return the current date and time. You can see this is the date value and then we have the current time. Alright, and this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first I showed you how you can see that databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database and then we created this table called employee details with column names like name, integer, the sex, date of join, city and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an or operator. We learned about in operator, the between operator. Then we used an and operator to select multiple conditions. Finally, we learned about group by, order by and some basic SQL operations. Now it's time to explore some string functions in MySQL. So I have given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now, instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu underscore name, and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. It is not readable actually. Let me also display the student names so that we can compare their length. Alright, I'll run this again, and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6, Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want, you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as, let's say, name underscore age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. we have the student ID, the student name, and the concatenated column that we created, which was name underscore age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse. I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse, and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is, let's say orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay, so what this replace function does is it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or L trim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is L trim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the L trim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference, as in you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4 and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6 and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here, if I just write trim and I'll run it, it gives me 5 because India is total 5 characters long and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place or at the 13th position we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. In this session, we are going to learn two important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having, and then jump into MySQL Workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement and then followed by the column names that we want to select. From, we have the table name followed by the where condition, and next we have the group by clause, and here we include the column names. Finally we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to. And then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department and then we are using an aggregate function, that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name, which is average underscore salary, which appears in the output, you can see here, from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL Workbench where we will implement group by and solve specific problems. Okay, so I am on my MySQL Workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query, that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer and I'll assign employee ID as my primary key. Next, I'll give employee underscore name and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join and the data type will be date. We have the department column as well. This is going to be of varchar and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information. And now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned and here are the department names. So we have sales, marketing, product, tech, IT, finance and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select avg, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says avg of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places, so I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright. Now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma. Now I want the total salary, so I'll use the sum function, and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next, we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 1 to 1 and let's say 1 to 3, since we have just 2 product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the 2 product IDs 1 to 1 and 1 to 3, and here you can see the revenue that was generated from these two products. Alright, now let's say we have to find the total profit that was made from both the products 1 to 1 and 1 to 3. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 1 to 1. Let's say the cost price was $270 for each, and next we have my product as 1 to 3, and let's say the cost price for product 1 to 3 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table, as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I'm using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 1 to 1, we made a profit of $1,100, and for product ID 1 to 3, we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function, that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause I'll use my condition, that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function, and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I am going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay. So let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. In this session we will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on MySQL Workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL workbench 8.0 version installed. I'll click on it. So it will take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay, so this is how an SQL editor on MySQL workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Control Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL Joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay. Now to understand inner join, consider that there is a college and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket_ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First let's load some data to our cricket table. So I'll write cricket and I'll give my name column, followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this, I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Aston. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case, you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So C dot name is equal to F dot name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select C dot cricket underscore ID, comma, C dot name, comma, F dot football underscore ID, comma, F dot name. From, I'll write cricket as C, inner join football as F, on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay, now let me just show the different tables that are part of classic tables. Alright, so here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright, so let me use my select statement to show what are the columns present in the products table. Okay, so this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product. Then we have the quantity in stock, buying price, and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright, now suppose you want to find the product code, the product name, and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description, so I'll write this column name. Okay, then I'll use from my first table, that is products, inner join product lines. I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes. Then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join three tables, that is orders, order details, and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product, we have the price of each product, then we have the order line number. Okay, so using the product, orders, and order details, let's perform an inner join. So I'll write select o dot order number, comma o dot status, comma I need the product name, which I'll take from the products table. So I'll write p dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD, on I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name and the revenue. This we got it using inner join from 3 different tables. Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have 2 tables, customers and orders. So if you want to find the customer name and their order ID, you can use these 2 tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are 2 address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O, on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing. There are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name, there were no orders. And similarly, if I scroll down, you will find a few more null values. You can see here there are two null values here for customer number 168 and 169. There were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about write joins. So SQL write join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the write join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, write join table B on the common key column from both the tables. Alright. Now to show how write join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, write join employees as E on E dot, my common key column is employee number here, so I'll write E dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see write join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056 the manager is 1002. So if you check for 1002 we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102 the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188 we have the manager as 1143. Now if I check the table at 1143 we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot. I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright. So that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL Joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next, we used a database called classic models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join, as well as full outer join.
So are you ready to get started with this amazing career? Check out postgraduate program in full stack web development by Simplilearn. So hurry up and enroll now. Find the complete course details from the link in the description box.
So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here, whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first, the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000. Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value, that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph. Alright, now we'll learn the different types of subqueries. So you can write subqueries using select statement, update statement, delete, and insert statement. We'll explore each of this with the help of example on my MySQL workbench. So let's learn subqueries with the select statement. So subqueries are majorly used with the select statement, and this is how the syntax looks like. You select the column name from the table name, then you have the where condition followed by the columns that you want to pass, the operator, and inside that you have the subquery. So here is an example that we will perform on our MySQL workbench. So in this example, we want to select all the employees who have a salary less than average salary for all the employees. This is the output. So let's do this on my MySQL workbench. Alright, so let me log into my local instance. I'll give my password. Okay, so you can see I'm on my MySQL workbench. So let's start by writing our subquery using the select statement. Okay, so for this demo session, we'll be using a database that is subqueries. You can see it here. I have a database called subqueries. So I'll use this subqueries database, and we'll create a few tables as well. Okay, if I run it, now we are inside the subqueries database. So let me just show you the tables that are present inside this database. I'll write show tables. If I run it, okay, there are two tables, employees and employees underscore B. We'll use this table throughout our demo session. Alright, now for our select subquery, we want to fetch the employee name, the department, and the salary whose salary is less than the average salary. So we will be using the employees table. So let me first show you the records and the columns we have in the employees table. So I'll write select star from employees and run it. Okay, you can see here we have 20 rows of information. We have the employee name, the employee ID, age, gender, date of join, department, city, and salary. So this is the same table that we saw in our slides. Okay, now for our subquery, I'll write select. I want to choose the employee name, the department, and the salary. There should be a comma here instead of a period. Next, I'll give my table name, that is employees, where my salary is less than, and after this I'll start my inner query or the subquery. I'll write select average salary. So I'm using the avg function to find the average salary of all the employees from my table, that is employees. If I give a semicolon and run this, you'll see the output. So we have total 12 employees in the table whose salary is less than the average salary. Now if you want, you can check the average salary. So the average salary is $75,350. Now the employees who have a salary less than the average salary, so these are the people. Alright, now moving back to our slides. Okay, now let's see how you can use subqueries with the insert statement. Now the insert statement uses the data returned from the subquery to insert into another table. So this is how the syntax looks like. So you write insert into table name followed by select individual columns or star from the table, use the where clause, and then you give the operator followed by the inner query or the subquery. So here we will explore a table called products table. We are going to fetch few records from the products table based on a condition, that is the selling price of the product should be greater than $100. So only those records will fetch and put it in our orders table. Alright. So we are going to write this query on my MySQL workbench. So let's do it. I'll give my comment as update subquery. Alright. So first of all, let's create a table that is products. So I'll write create table products. Then we'll give our column names. The first column would be the product ID of type integer. Then we have the column as item or the product, which is of type varchar 30. Next we have the selling price of that product. The selling price will be of type float. And finally we have another column which is called the product type. And again product type is of the data type varchar. I'll give the size as 30, close the bracket and give a semicolon. Now let's just run it. Okay, so we have successfully created our products table. Now let's insert a few records to our products table. So I'll write insert into products followed by values. I'll give 4 records. The first product ID is 101. The product is, let's say, jewelry. Then the selling price is, let's say, $800, and the product type is, it's a luxury product. Next, let's insert one more product detail. The product ID is 102. The product is, let's say, t-shirt. The price is, let's say, $100, and the product type is non-luxury. Next, I'll just copy this to reduce our task. We'll edit this. The third product's ID is 103. The product is laptop, and let's say the price is $1,300, and it's a luxury product. I'll paste again, and finally I'll enter my fourth product, which is, let's say, table, and the price is $400, and it's a non-luxury product. I'll give a semicolon and we'll insert these 4 records to our products table. You can see we have inserted 4 records. Let's just print it now. So I'll write select star from products. If I run it, you can see we have our 4 products ready. Now we need to create another table where we are going to put some records from our products table. So that new table is going to be the orders table. So I'll write create table orders. Now it will have 3 columns. The order ID will be of type integer. Then we have product underscore sold. This will be of type varying character of size 30, and finally we have the selling price column. This will be of type float. Let's create our orders table. The table name should be orders, and there is some mistake here. Okay, you should close the brackets. Okay, let me run it. So we have our orders table ready. Now let's write our insert subquery. So I am going to insert into my table, that is orders, and I'll select the product ID, comma, the item and the selling price or the sell price from my table, that is products, where I'll write product ID in, I'll write my inner query select prod ID or the product ID from products. Next I'll give a where clause where the selling price is greater than $1,000. So let me tell you what I am going to do here. I am going to insert into my orders table the product ID, the item name and the selling price from my products table, where the product ID has this condition. So let me first run this condition for you, which is select prod ID from products where the selling price is greater than 1000. If I run this, okay, there is some issue here. The column name is actually prod ID. Now let's run it again so that we can see the product IDs of the products which have a selling price greater than 1000. So it is 101 and 103. Now let's run the entire query. There is another mistake here. Let's debug the mistake. Now this should be product ID instead of product underscore in. Let's insert again. Alright, so we have successfully inserted two records to our table, that is orders. Now let's see the orders table. I'll write select star from orders. If I run it, there you go. So there were two products from our product table that were jewelry and laptop, which have a selling price greater than $1,000. So the selling price for jewelry was $1,800 and for laptop it was $1,300. So this is how you can use a subquery using the insert statement. Alright, now going back to our slides again. Alright, now let's see how you can use subqueries with the update statement. Now the subqueries can be used in conjunction with the update statement. So either single or multiple columns in a table can be updated when using a subquery with the update statement. So this is how the basic syntax of an update subquery looks like. So you write update table followed by the table name, you set the column name, you give the where operator, and then you write your inner subquery. So we are going to see an example where we will use this employees table, and using this employees table we will update the records of the salaries of the employees by multiplying it with a factor of 0.35 only for those employees which have age greater than 27. So we are going to use a new table called employees underscore b for this as well. So let's see how to do it. So I'll give my comment as update subquery. Before we see the subquery, let's see what we have in the table employees underscore b. This is basically a replica of the employees table. There you go. It has the same records that our employees table has. We are going to use both the employees table and the employees underscore b table to update our records. So I'll write update employees set salary equal to, let me bring this to the next line. I'll write set salary equal to salary multiplied by 0.35, where age in, then I'll write select age from my other table, that is employees underscore b, where age is greater than or equal to, let's say 27. Alright, so let me run through this query and tell you what we are going to do. So I'm going to update the records of the employees table specifically for the salary column. So I'm checking If the age is greater than 27, then we'll multiply the salaries of the employees with a factor of 0.35 in the employees table. Let me just run this, then we'll see our output. Okay, so it says 18 rows affected, which means there are total 18 employees in the table out of the 20 employees whose age is greater than 27. Now if you see, I'll write select star from employees. You can see the difference in the salaries. If I scroll to the right, you can see these are the updated salaries. Okay. Now if you check for employees who have an age less than or equal to 27, for example Marcus, whose age is 25, his salary is the same. We haven't updated his salary. Then if you see, if we have, okay, there is one more employee, Maya. We haven't updated the salary of Maya because the age is less than 27. Alright. Now let's go back to our slides again. As you can see, we got the same output on our MySQL workbench. Now let's explore how you can write subqueries with the delete statement. Now subqueries can again be used in conjunction with the delete statement. So this is how the basic syntax of a delete query using subquery would look like. You write delete from the table name, where clause, the operator value, followed by the inner query in within brackets. So here we are going to use the employees table, and what we are going to do is we'll delete the employees whose age is greater than equal to 27. So let's see how you can do it. Alright, so I'll give my comment as delete subquery. So we'll follow the syntax that we saw. I'll write delete from my table name, that is employees. I'll write where age in, and then I'll start my inner query or the subquery. I'll write select age from employees underscore B, where age is, let's say, greater than equal to 32, or let's say the age is less than equal to 32. Close the bracket and I'll give my semicolon. Let me first run the inner query for you so that you get an idea of the employees who are less than 32 years of age. So there are 9 employees in the table who have an age less than equal to 32. So we are going to delete the records. If I run this, okay, it says 9 records deleted. Now let's print or display what we have in the employees table. If I run this, there you go. So if you see the age table, we have total 11 employees now, and all their ages are greater than 32 because we have deleted all those employees who had an age less than equal to 32. Okay, so let me show you from the beginning what we did. So first we used our subqueries database, then we used our employees table. So we started by looking at how you can use the subquery with a select statement. This should be insert instead of update. So we learned how to write an insert subquery. We use two tables, products and our orders table. Moving ahead, we saw how to write subqueries using the update command. So we updated the salaries of the employee by a factor of 0.35 for those who had an age greater than equal to 27. And finally, we saw how to use the subquery using the delete statement. So we deleted all those records for the employees whose age was less than equal to 32. In this video, we will discuss an advanced SQL concept called triggers. We will learn what triggers are and how they can be used to solve problems. We'll look at how trigger queries are written on MySQL workbench. So let's get started. First, what are triggers in SQL? So a trigger is a user-defined SQL command that is invoked automatically when an event occurs, An event can be related to inserting, updating, or deleting records in a table. In MySQL, triggers can be executed automatically by the Oracle server. Below is how the syntax of writing a trigger is. So you write create trigger followed by the trigger name. Now the trigger name should be a valid SQL name. Then we have the trigger time, the trigger event, and then on the name of the table. Then we write for each row begin followed by the list of SQL statements, and finally we write end. Now in the syntax, the trigger time represents either before or after an event, and a trigger event can be an insert, update, or delete operation. Now let me take you to MySQL Workbench, where we will learn how to create triggers and explore more on how it works. So I am on MySQL Workbench. So first let me go ahead and create my connection. I'll give my password. Alright, now this will take you to my SQL editor. Okay, so first and foremost, let me create a new database called triggers. So I'll write my SQL command as create database triggers. Let me run this. Okay, so you can see here one row affected. I have created my database, that is triggers. Next, I'm going to move inside this database, so I'll write the command use triggers. Let's run this. Okay, now inside this triggers database, we'll be creating our different tables. So let's check if we have any tables. I'll use the command show tables. Now you see there are no tables in this database. Alright, first let's see how before insert trigger works. So for before insert trigger, we'll create a table called customers and verify the age of each customer. So I'll give a comment before insert trigger. So let me go ahead and create my customers table. I'll write create table customers, and I'll give my column names as cust_id, which is customer ID. This is going to be an integer. Then we have the age of the customer. This is again an integer, and we'll have the name of the customer. The name of the customer will be of varchar type. I'll give the size as 30. Alright, let's create this table. Okay, so we have successfully created our customers table. Now moving ahead, I'm going to write my before insert trigger command. So we'll start with a delimiter. So a delimiter is a marker for the end of each command. Next, I'll write my create trigger followed by the trigger name. I'll give a valid trigger name such as age_verify. I'll write before trigger. It should be before insert on. My table name would be customers. Then I'll write for each row if new dot age is less than 0, then set new dot age equal to 0, which means while inserting your values to the age column, in case the age value is negative, will convert the age to 0. I'll give a semicolon, and then I'll write end if. I'll give another semicolon, and I'll close the delimiter. Now let me run this. Okay, so we have created our trigger. Now let's insert a few values onto customers. So I'll write insert into customers values 101, which is the customer ID. I'll give the age as 27 and let's say the name of the customer is James. Let's insert another record, give the value as 102, and this time I'm purposely giving the age as -40, which is less than 0, so that you can see the output clearly. I've given the customer name as Amy. Let's insert two more records. The customer ID with 103 has an age of 32, and let's say the name is Ben. I'll give another comma, and finally we'll insert our fourth customer record. The customer ID is 104. The age I'm giving as -39, which is less than 0 again, and let's say the customer name is Angela. Alright, now let me run this. Okay, so we have successfully inserted 4 rows of information to our customers table. Now let's see the difference. Since we had created a age verify trigger which would change the values of the age column in case the age value is less than 0. So now that we have inserted 4 records to a customer, so let's see what we have in the customers table. Now let me run it. There you go. So if you see this, for those customers where the age was less than 0, such as 102 and 103, you can see here our trigger has automatically converted those values to 0. If you can see the trigger we had created, we had set our new age to 0 if the age was less than 0, and this is the output we get. So here we looked at how a before insert trigger works. Alright, now moving ahead, let's understand how an after insert trigger works. So I'll give a comment here as after insert trigger. Now in this example, we'll create two tables, customers and message. Now the trigger will be fired if the birthday column has a null value in the customers table. You will get a message to update your date of birth. Okay, so first let me create my customers table. Now since we already have one customers table, I'll name it as customers 1, and let me give the column names. So the first column would be the ID column. This is going to be an integer, and I'll use the auto increment parameter, and this will be my primary key as well. Next we'll have the name of the customer. This is going to be of type varchar, and I'll use not null constraint. Next we'll have the email ID of the customer. This is again going to be of varchar type, and the column we are interested in is the birthday column. So I'll write birth date. This is going to be of type date. Okay, so let's create our table. Alright, now we'll create our second table, which is going to be message. Let's create the columns. This will have ID, int, and I'll use the auto increment operator. Next we'll have the message ID. This is going to be of integer type. We'll have a column called message. This will be of varchar type, let's say 300 characters, and not null. And I'm going to set my primary keys as ID and message ID. Let's create our second table then. So we have some error here. Let's debug the error. Okay, so I forgot to close the bracket here. Alright, now let me run this table. Alright, so we have created our message table as well. Next, I'll write my after insert trigger command. So I'll write delimiter. Next, I'll use create trigger command. So I'll write create trigger. My trigger name would be check underscore null underscore date of birth. After insert on customers 1 for each row begin if new dot birth date is null, then we are going to insert into our message table. We'll give the columns as message ID and message values new.id, comma, I'm going to use the concat function where I'll give my message, let's say hi, followed by the name, followed by, let's say, please update your date of birth. Okay, now I'll write end if. I'll close the delimiter. Okay, so let me go to the top and recheck if we have created our trigger correctly. So I have my trigger name after insert on customers 1 for each row begin if our new birthday has a null value, then we'll pass in a message saying hi, the name of the customer, then the message would be please update your date of birth. Alright, so let's run the trigger. Okay, now the next step is to insert a few records to customer table. So my name of the table is customers 1. Okay, I'll give the column names as name, email and birth. Okay, we'll pass in a few values. So our first customer's name, let's say, is Nancy, comma, I'll give my email ID, let's say nancy@abc.com. Now let's say I'm purposely passing the date of birth as null. I'll give a comma. My next customer, let's say the name of the customer is Ronald, and then I'll give the email ID such as ronald@xyz.com, and this time I'm going to pass in the date of birth, let's say 1998 November, and let's say 16th. Okay, now we'll add another customer, let's say Krish. We'll give the email ID of Krish, so krish@xyz.com, and let's say we'll give the date of birth as 1997 08/20, and finally we'll add one more record for another customer, let's say Alice. I'll give the email ID as alice@abc.com, and this time I'll purposely pass the date of birth as null. Alright, so let's run the insert query. Okay, now let me display the message table for you so that you can see the output and how our after insert trigger works. There you go. So if you see this, we had inserted 4 rows of information, out of which the first customer ID and the fourth ID had null date of birth. So for those two values, you have the message as "Hi Nancy, please update your date of birth," and then you have "Hi Alice, please update your date of birth." Now you can give a space between "Hi" and the name of the customer. Alright. Now moving ahead, let's understand how before update trigger works. So I'll give a comment here as before update. Okay. Now to show you how before update works, first we'll create a table called employees. Alright. So let me create my table, that is create table employees. I'll give my column as employee ID. This is going to be an integer type and it will be my primary key. Next we'll have the employee name. This will be of varchar type, and let's say the size would be 25, comma, then we'll have the age of the employee. Age will be of integer type, and finally we'll have the salary of the employee. Salary will be of type float. Let's create this table. Alright, now the next step is to insert a few records to our employees table. Okay, so here on the notepad I have already written my insert query. So I have inserted nearly 7 records. So let me paste it here. Alright, I'll just go ahead and run this insert query so that we'll insert 7 employees to our table. Okay. Next, we'll write our before update trigger command. So first and foremost, I'll write my delimiter followed by the create trigger command. I'll give my trigger name as update underscore trigger. Let's bring this to the top. Okay. I'll use before update on my table, that is employees. For each row I'll write begin. My condition would be if new dot salary is equal to, let's say, $10,000. I'll write then set new dot salary equal to $85,000. I'll give a semicolon. Then I'll use else if new dot salary is less than $10,000, then I'll set new dot salary to, let's say, $72,000. I'll give a semicolon. I'll end the if statement. I'll close the delimiter by giving a semicolon. Okay, so if you see the employees table, we have the salary values here. Now in case while updating the table, if the salary is equal to $10,000, we'll set the new salary to $85,000, Else, if the salary is less than $10,000, we'll set the salary column values to $72,000. So let's go ahead and run this trigger query. Alright, now let me use my update command. So I'll write update employees. I'll write set salary is equal to, let's say, $8,000. Now if you see our trigger query, we are setting the salary to $8,000, which is clearly less than $10,000. So our new salary would be $72,000. So let me run this. Okay, so you can see here 6 rows affected. So I'll write now select star from employees. Let's run this. Okay, if you see this, we have converted our salary column to $72,000 since we updated the salary to $8,000, and according to our trigger query, if it's less than $10,000, the salary should be $72,000, which you can see here. Alright, now moving to our final demo. This time we are going to explore how before delete trigger command works. So in this example, we'll create a table called salary. We'll store the deleted record in a new table using the before delete trigger. So first, I'll give my comment as before trigger. Comments are always useful since they make your query more readable. So let me now create my salary table. So I'll write create table salary. I'll give my column names as EID, which is employee ID, and I'll set it as primary key, comma, I'll give another column, let's say valid from, which means the date from which this salary was effective. This is going to be of type date and not null. And then I'll have the amount. Amount will be of type float, and again not null constraint. Let me run the create table command. Okay, so we have created our salary table now. The next thing is to insert a few values. So I'll write insert into salary. I'll give my column names as EID, comma, valid from, comma, amount. I'll write values. My first employee ID would be 101, followed by a date, let's say 2005, May, and 01, which is 1st of May 2005. Let's say the amount is $55,000. I'll give another row of information. This time the employee ID is 102, and I'll give a valid from date. Let's say the amount is 68,000. I'll give another employee ID, let's say 103, 2006, 0901, and let's say the amount is $75,000. Okay, let's run this. Alright, you can verify also. So I'll write select star from salary. You can see here we have inserted 3 rows of information. Alright, the next step is to create another table that will store the deleted rows. So I'll write create table. Let's say the name of the table is create, or let's say salary delete. I'll write salary del. Now this will have the ID, the type would be integer, and primary key, I'll also use the auto increment operator. Next we have the EID, which is of type integer. I'll write valid from date and not null. Then I have the amount column, which is of type float and not null. My final column would be deleted at. The data type will be timestamp. I'll use the default constraint as now. So this will return the time and the date at which the record was deleted. Alright. Let me create this table. Okay. Finally, let me write my before delete trigger command. So I'll first declare my delimiter. Let's say this time I'm using the dollar symbol. I'll write create trigger. My trigger name would be salary underscore delete before delete on my table, that is salary. For each row I'll write begin. Next, let's insert into salary delete. I'll give my columns as employee ID, valid from, and amount. Now we'll insert a few values. I'll write values old dot eid comma old dot valid from comma old dot amount. I'm going to close with the delimiters. Alright, so let's run our before delete trigger. Alright, now let me go ahead and delete one of the records from the salary table. So I'll write delete from salary where employee ID is, let's say, 103. Let me run this query. Okay, so you have successfully deleted one of the records in the table. Now if you see our other table, that is salary delete, you will find this information present in the salary delete column. So we had deleted one row of information, that is for employee ID 103, which you can find it here. Now the final column, that is delete at, shows the time at which the information was deleted or the row was deleted. Alright, so let me go to the top and just give you a recap of what we did in this demo. So first we created a database called triggers. Then we started with before insert trigger, where we inserted customer table, and then we verified the age of the customers. So we saw if the age was less than 0, then we set the age to 0. We inserted a few records to the customers table, and purposely we inserted some negative age records, and then we converted this age records to 0. Then we learned how an after insert trigger works. So we created two tables, customers 1 and message. So wherever the customer's date of birth was missing, we passed in a message saying, hi, the name of the customer, please update your date of birth. Alright, now moving ahead, we saw how before update trigger works, and finally we learned about before delete trigger. So in this video we will learn subqueries in SQL. We'll also have a look at stored procedures and learn about triggers in SQL. We'll cover views in SQL and look at some of the important Windows functions in SQL. Now to learn all of these, we'll be using the MySQL workbench on Windows. So let's get started with subqueries in SQL. So let me head over to my MySQL workbench. So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright, so this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select. I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than. I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is, I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was $. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top_players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now, there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL underscore IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var which I created here. I'll end my select statement. I'll end my stored procedure with / and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is SP underscore sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is SP underscore sort by salary, the other 2 were top underscore player and top underscore players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is SP underscore sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now instead of a select statement inside a stored procedure, you can also use other statements, let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /, then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name, I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore emps, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to / I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore emps, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female. I'll give a semicolon. Next, I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore emps. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total underscore emps. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets, I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure, and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table, which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter, like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting. If any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own, but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust_details. Then you write as select. I'm going to select a few column names from my original customer table, which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright. I'll write from my table, that is customers. If I run this, my view, that is cust details, will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name, that is cust_details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that I am going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside Classic Models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there's some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product_description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table. I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to I'll give a space PL dot product line. Okay. So here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay. Now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cost details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright, now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay, I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma, next I'll write the sum of salary over, I want to partition it by department, so I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright, now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary, so I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table, so I'll write insert into demo values. I'll give 101, the name is Shane, give a comma. I'll insert the second student name 102, the name is Bradley, I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma, I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over, within brackets I'll write partition by st underscore id, comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane, we have one student in the name Bradley, but here if you see for Herath, the second record it says 2, which means there are 2 records for Herath, and if I scroll down there is 1 record for Nathan and there are 2 records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when 2 or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable, that is var underscore a, as an alias name, let's say test rank, from my table, that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function assigned the same value, which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function, which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value which is my function, and pass in my employee name, and then I'll write over order by my column, that is salary descending. I'll give an alias as highest underscore salary from my table, that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table, Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function, that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table, that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL, which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions. In this tutorial, we will learn how to work with databases and tables using SQL with Python. To do this demo, we will be using our Jupyter notebook and the MySQL workbench. You can see it here. So we will write our SQL queries in the Jupyter notebook with Python-like syntax. If you don't have MySQL or Jupyter notebook installed, so please go ahead and install them first. While installing the MySQL workbench, you will be asked to give the username and password. Let me show you. So I am on my MySQL workbench. So once you connect, it will ask for the username and the password. So I have given my username as root, and password you can give while installing it. We will be using the same user ID or the username and the password to make our connection. So let's get started with our hands-on demonstration part. First and foremost, let me go ahead and import the necessary libraries. I'll give a comment as import libraries. Alright, so first I'll import MySQL.connector. Next, from MySQL.connector, I'm going to import my error method or the error module. Next, I want to import pandas as PD. So let's run this. Okay, there is some error here. This should be capital E and not small e. Alright, you can see I have imported my important libraries. Now I'm going to create a function that will help us create a server connection. So I'll write my user-defined function by using the def keyword. I'll write create underscore server underscore connection. This is going to be my function name, and it will take in 3 parameters. First is the host name, next is the username, and then we have the user password. Alright, I'll give a colon, and then in the next line I'm going to define a variable which is going to be connection, and I'll assign it to a value called none. Now we'll be using exception handling techniques to connect to our MySQL server. The try block lets you test a block of code for errors, and the except block will handle the errors. So I'll write try and give a colon, and then I'm going to reassign the connection variable to a method which is mysql.connector.connect. Now this mysql connector.connect method sets up a connection, so it establishes a session with the MySQL server. If no arguments are passed, it uses the already configured or default values. So here we are going to pass in 3 parameters. The first is the host name. I'll write host equal to host name, which is host underscore name. I'll give a comma, then I'll write user equal to user underscore name. Next will be my password, and I'll assign the value user underscore password. Alright, now I'm going to use a print statement and write MySQL database connection successful. After this, I'll give my except block. So I'll use the keyword except. Here I'll write error as err, give a colon, and then I'm going to use the print statement. Here I'm going to use some print formatting techniques using the F letter. I'll write error colon, and I'll use curly braces, give err, and then I'll close the double quotes. After this, I'm going to return my connection. Alright, let me give a comment here. We are going to assign our password, so we need to put our MySQL terminal password. So this password you assign it while installing MySQL Workbench. I'll write pw and I'll give my password, which is simply@123455, and then I'm going to give my database name. So I'll give database name. Here I'm going to write db equal to, this is the database I want to create, which is going to be MySQL_Python. Let me just scroll this down. Okay, now I'll say connection equal to, I'll pass in my user defined function name, which is create server connection, and the parameters, which are going to be localhost, that is my host name, my username, which is root, and then I'll give pw, which is my password, that is exactly simply@123455. Let's just run it now. Okay, there is an error here. We need to remove this double quotation. Alright, made another mistake here. This should be root. Okay, you can see here MySQL database connection successful. Alright, next we are now going to create a database, that is MySQL_Python. So I'll give a comment, create MySQL_Python database. Again, to create this database, I'm going to create another user defined function using the def keyword. I'll write the function name as create database, pass in the parameters as connection, query, give a semicolon, and in the next line I'll write cursor equal to, I'm going to make the connection, so I'll write connection dot cursor, and I'll give the parenthesis. So this MySQL's cursor of MySQL connector Python is used to execute statements to communicate with the MySQL database. The MySQL cursor class initiates objects that can execute operations such as the MySQL statements. Okay, next I'm going to again use my try and accept block. So I'll write try, give a colon, and here I'm going to use cursor dot execute. Within that I'm going to pass in my query. Next I'll use a print statement, and the message I'm going to display is database created successfully. After this I'm going to write my accept block. I'll write accept error as err, give a colon, and then I'll use a print statement. I'll write print, I'll use the formatting again, error colon, and I'll write within single quotes, I'll give curly braces err, and then I'll close the double quotes. Next let's use the variable create underscore database underscore query, and here I'm going to write my SQL query to create the database. So I'll write create database, and followed by that I'll give my database name, which is going to be mysql_python. Okay. After this, I'll call my function, which is create database, and I'll pass in the parameters. The first one is connection, and next the query is create underscore database underscore query. Let me just copy it, and I'm going to paste it here. Alright, so what I am doing here is I am creating a new function, that is to create a new database with the name MySQL underscore Python, which you can see it here. Now this function takes in two parameters, connection and query. I'm using the connection.cursor function, which is often used to execute SQL statements using Python language. And then I have created my try and except blocks. So this try block statements will try to create my new database, which is MySQL underscore Python. In case it fails to create the new database, the except block will work. So here I am writing my SQL query to create a new database, which is create database followed by the database name, and I am assigning it to a variable which is create database query, and then I'm calling my function create database and passing in the two parameters, connection and the query. Alright, so let's just run it. Alright, you can see here it has created my database successfully. Now you can verify this by checking the MySQL workbench or the MySQL shell. You can see on the MySQL workbench here on the left panel under schemas, there is a database called MySQL underscore Python. Let me just expand it. Now we haven't created any table, so it's not showing it now. The next step, we are going to connect to this database. So let's go ahead and connect to our database that we have just created. I'll write the comment as connect to database. Now to connect to our database, I'm again going to create a user defined function using the def keyword. I'll write create underscore db, which is for database underscore connection, and the parameters it will take is the host name followed by the username, then we have the user password, and finally we have the database name. I'll give a colon. In the next line, I'm going to create my variable which is connection, and then I'll assign it to a value none. After this, I'm going to use my exception handling techniques. So I'll write my try block first. I'm going to reassign my connection variable using the MySQL connector method. So I'll write MySQL dot connector dot connect. So this method will take in the parameters. So first it will take the host name. I'll write host equal to host underscore name. I'll give a comma. Next it will take the username, so user equal to user underscore name, give another comma. Next it will take the user password. I'll use passwd equal to user underscore password. I'll give another comma, and this time it is going to be the database name. So I'll write database equal to db underscore name. Now let's use the print statement, and the message we are going to print is MySQL database connection successful. Alright, finally we'll write my except block. I'll write except error as err, give a colon, and then I'll use the print statement f within double quotes I'll write error colon, within single quotes curly braces I'll write err, and will close the double quotes. Finally, this function will return the connection value. Alright, let's run it, and there you go. It has run successfully, so we have connected to our database. Now it's time for us to execute SQL queries. I'll give another comment saying execute SQL queries. Alright, now to execute our SQL queries, I'll use another user-defined function, which is execute underscore query, and I'll pass in the parameters as connection and query. I'll give a colon. I'm going to write cursor equal to connection dot cursor. Now this is used to establish a connection and run SQL statements. Next, we'll use the try and except block, so I'll write try cursor dot execute. This will take in one parameter, which is going to be my query, and then I'll write connection dot commit, which is another method. Now let's use the print statement. So I'll write print. Let's say the message would be query was successful. And then we'll write our except block, which is except if the try block doesn't work, throw an error using the print statement. Within double quotes, inside the curly braces, I'll write err and close the double quotes. Alright, so let's run it. Okay, so we have successfully created our various functions that were needed to create a database, establish a connection, and to execute our queries. Alright, now it's time for us to create our first table inside the MySQL_Python database. So to do that, I'm going to write my create command in SQL. So first we are going to assign our SQL command to a Python variable using triple quotes to create a multi-line string. So let me show you how to do that. I'll write my variable name, which is going to be create orders table. It is always recommended to use relevant variable names to make it more readable. And now I'm going to use triple quotes. So the triple quote will ensure I can create my multi-line string. Inside the triple quote, I am going to write my create command, which is create table. Here I am going to create an orders table first, and inside the orders table I am going to create my column names. The first column would be the order ID. It is going to be of type integer, and I'll assign this order ID as my primary key column. We'll give a comma. Next, the second column would be customer underscore name. The customer name column would be of type varying character, so I'll write varchar and I'll give a size of 30, and this is also going to be not null. Moving ahead, my fourth column would be the product name column, so I'll write product underscore name. Product name will be of type varying character. The size is, let's say, 20, and it is also not null. Next, I'm going to create my fourth column, which is the date on which the item was ordered or the product was ordered. So I'll write date ordered. The data type will be date. Next, I'll create a quantity column to keep track of the number of quantities that were ordered. This is of type integer. My next column would be unit price, which will basically have information about the price of each unit of product. Unit price can be of type float. And finally, I'll have the phone number of the customer. I'll write phone number. Phone number can be kept as of type varying character. I've assigned a size of 20. Now let's give a semicolon and we'll close the triple quotes. Alright, so this is how the syntax would look like. Next, to run this, we are first going to call our createDB function. So let me give a comment as connect to the database. I'll write connection equal to create underscore db underscore connection. My parameters would be my host name, which is localhost, my username, which is root, comma, my password, and then my database name, which is MySQL underscore Python. So I'll write just db. Alright. Finally, let's execute this query using the execute underscore query function that we had created earlier. This takes in two parameters. The first one is connection, followed by the variable name, which is create orders underscore table. Let us run it. Okay, there is some error here. Let's see what's the error. Okay, so here we have put 4 double quotes. This should be triple quotes. Now let's run it. Okay, there is another here. Let's debug it. It says name cursor not defined. Let me just roll it to the above cell. If you see here in our execute underscore query function, instead of cursor, I have written cursor. So R is missing. Let's rerun this. And now let's run this again. There you go. You can see here MySQL database connection successful. Even our query was also successful. Now if you want to recheck if the table, that is orders, was created or not, you can check it on the MySQL workbench. So let me show you how to do it. So I am on my MySQL workbench, and under MySQL underscore Python database you have something called as tables. Let me just right click and I'll select refresh all. There you go. You can see this arrow. Just click on this arrow and here you can see we have a table called orders. So we have created a table called orders. Now you can check the columns as well. You have the order ID, the customer name, product name, ordered date, quantity, unit price, and phone number. Now it's time for us to insert a few records to this table, which is orders. Now to insert records, I'll give a comment as insert data. I'll start with the variable name. Let's say the variable name is data underscore orders. I'll give triple quotes. Next, I'll write my insert into command. So I'll write insert into my table name, that is orders, followed by values, and now I'll start entering my records for each of the rows. So first I'll give 101, which is the order ID. Then I'll give the customer's name, let's say Steve, and the product he had ordered is, let's say, laptop. Then I'll give my date in which the item was ordered. Let's say it is 2018. I'll choose 06 as the month and the date is, let's say, 12. We'll give another comma. This time we'll pass in the quantity, which is 2. Let's say the price of each laptop was $800, and we'll give a phone number. This is random. Let's say 62937330. Let's say 802. Alright. Similarly, I am going to insert 5 more records of different customers and their items that they have purchased to this table orders. So here on my notepad I have my rest of the 5 records. Let me just copy it and we'll paste it in the cell here. This will save us some time. Okay, let me recheck if everything is fine. I'll give a comma here. Alright, so we have 6 customers in our table which have their customer IDs from 101 to 106. We have Steve, Jaws, Stacy, Nancy, Maria and Danny. You have the different items they have purchased: laptop, books, trousers, t-shirts, headphones and smart TV. This is the date on which they had ordered this item, the number of quantities they had ordered, and then we have the unit price and some random phone numbers. So let's create the connection now. I'll write connection equal to, I'll write create underscore db underscore connection. Then I'll going to give my same parameters. Let me just copy it from the top, which is localhost, the host name, root is my username, then we have password and the database name, and then I'll use the same query as above, which is execute query. I'll copy this, paste it here, and instead of create orders table variable, I'll put as data underscore orders. So this will store my insert into command. You can see the variable I have used here is data underscore orders. Now it's time, let's just run it. Alright, there was some mistake here. Let's debug it. Again, this should be triple quotes and not 4. Now let me rerun it again. There you go. You can see here MySQL database connection successful and my query was also successful. Now we'll create another user-defined function which will help us read query and display the results. So I'll write my function name as def read underscore query. This will take in 2 parameters, connection and query. Then I'll write cursor equal to connection.cursor. I'll put my result as none, and then I'll use my try and accept block. I'll write try cursor dot execute. This will take in 1 parameter, which is query, and then I'll give another variable which is result equal to cursor dot fetch all. Now this fetch all method will return all the results in the table. I'll write return result. Next we'll use the accept block. So I'll write accept error as err, give a colon, and I'll use my print statement. Scroll this down. I'll use my formatting f error, give a colon followed by a space, within single quotes inside curly braces I'll give err and close my double quotes. Let's run it. Alright, so now we are all set. Now we are going to use our select clause, having, whereby, then we'll see how to use order by clause, some inbuilt functions, we'll update some records, delete some records, and do a lot of other stuff. So let's start with our first query. So our first query is going to be using the select statement. Alright, so suppose I want to display all the records that we have inserted into our orders table So the way to do is, I'll assign my query to a variable, let's say Q1. I'll give triple quotes. Within triple quotes, I'll write select star from orders. I'll give a semicolon followed by the triple quotes. Now we'll establish the connection. So let me just go to the top and I'll copy this line, which is to connect to our database. I'll paste it here. Now we'll create a variable called results that will store the result of this query, and we are going to assign this variable to our function, that is read query, and this read query will have two parameters, the connection and the variable name, which is Q1 for the query. Next, to display, I'm going to use a for loop. I'll write for results for result in results print, I'll say result. Now we are done. Let's just run this query. There you go. You can see here we have successfully printed all the rows in our table, which is orders. You can see we have 6 records in total. Now we are going to explore a few more queries. So let me just copy this and we are going to edit in the same query. I'll paste it here. Next, let's say you want to display individual columns from the table and not all the columns. So let me create the variable Q2. Now instead of star, I'm going to display only the customer name and let's say the phone numbers of the customer. So I'll write phone underscore number. Alright, the rest all remains the same. Let me just recheck it, and here instead of Q1 we'll put Q2, and let's run this cell. Alright, you can see here now we have displayed only 2 columns. The first column is the customer name and then we have their respective phone numbers. Okay, now let me just paste that query again. Now we are going to see how you can use an inbuilt function, that is, in our table we have the order date, and from the order date we are only going to display the different years that are present in the order date. So to do that, I am going to use the year function. I'll edit this query. Instead of Q1 I'll make it Q3, and here I am going to write select year, which is my function name, from my column which is date ordered, from orders, and here I'll change this to Q3. Q1, Q2, Q3 are basically query 1, query 2 and query 3. Let's run it. There you go. So we have successfully extracted the different years present in the order date column. Now if you want to display the distinct or the unique dates present in the column, you can use the distinct keyword in the select statement. So the way to do it is, I'll write select distinct, give a space, the rest of the query remains the same, and here in Q3 I'll write Q4. I'll make this as Q4. Let's run it. You can see 2018 and 2019 are the unique year values that are present in the order date column. Okay, now moving ahead, let's write our 5th query, and this time we are going to explore how you can use the where clause. So I'll change this to Q5 before I write my query. So let's say you want to display all the orders that were ordered before 31st of December 2018. So to filter this, we are going to use the where clause. So I'll write select star from orders. Next I'll write where my date underscore ordered is less than, within quotes I'll give my date value, which is 2018 December 31st. So all the items or the products that were ordered before 31st of December 2018 will be displayed. So let's run it. Alright, you can see here there are 3 orders in our table which have been ordered before 31st of December. Now moving ahead, we want to display all the orders that were made after 31st of December. So here what you can do is, I'll just copy the above query again. I'll copy this line. So instead of less than 31st of December 2018, I'll make it as greater than. So every order that was placed after 31st of December will be displayed. If you run it, so you can see here there are 3 orders in our table which were ordered after 31st of December 2018. Now moving ahead, let's write a 7th query. Now let's see how the order by clause works in SQL. So you can filter your results based on a particular column or sort it based on a particular column. So this is going to be my query 7. I'll write it from scratch again. Let's say you want to display all the columns from the table. So I'll write select star from orders. Then I'm going to use order by unit price. I'll give a semicolon. Let's run this query and see the output. Now if you see the result here and you mark the unit price column, the result has been ordered in ascending order of unit price. You see here it starts with the lowest price and then goes on with the highest price towards the end. Now if you want to order it in descending order, you can use the keyword DESC. So this will ensure your top or the most expensive products appear at the top and the least expensive products appear at the bottom. Alright. Next. Now let's see how you can create a data frame from the given table. So as you know, using Jupyter Notebook and Pandas, you can create data frames and work on it very easily. So with this table also we can create our own data frame. So for that, let me create an empty list first. I'll write from db equal to, I'll assign this as an empty list. So we are going to return a list of lists and then create a Pandas data frame. Next, I'll write my for loop. I'll write for result in results. I'll assign result to list of results. So I'm converting the result into a list and then I'm going to append it to the empty variable or the empty list, which is from underscore db dot append. I'll append the result to my empty list. Next, we need to pass in the columns now that will be part of our data frame. So I'll write columns equal to this column. I'll pass it within a list. So I'll give my first column as order ID. Then we have the customer name. Next, I have my product name. Then I have the date on which it was ordered. Give a comma. Then we'll have the quantity column. Let me write it in the next line. Next, we have the unit price column. And finally, we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd dot data frame, which is my function to convert a list into a data frame. My variable I'm going to pass is from underscore db, and I'll write my next argument is columns equal to my variable name, that is columns. Finally, let's display the data frame which is df. Alright, so here I am creating a empty list first, and then I am creating a for loop, and I am appending the results to my empty list. Here you can see I have created my column list, and using pd.dataframe I'm converting the list into a data frame. If I run this is append and not appends. Alright, you can see we have our data frame ready. This is the index column, it starts from 0 onwards, and then we have the different column names. Okay, now let's see how to use the update command. Now suppose you want to change the unit price of one of the orders, you can use the update command. So the way to do it, I'll first create my variable, let's say update, and I'll give 3 quotes or triple quotes. Then I'll use my update command, which is update followed by the table name, that is orders. Next I'll write set, let's say unit underscore price. If you see this, let's say I want to set the unit price of trousers from $50 to, let's say, $45. I want to update this particular record, so I'm going to write set unit price column equal to $45, where the order ID equal to 103. So this query will update the third row in our table, which is order ID 103. So it will update from $50 to $45. I'll close the triple quotes, and now I'll use the connection queries again. Let me just paste it here. Alright, I'll delete these 3 lines of code, and instead of that I'll put execute underscore query, and this will take into parameters as always, which is going to be connection followed by the variable name, that is update. Let's run it. You see here it says MySQL database connection successful, query was successful. Now you can recheck that. To do it, let me just go to the top and we'll just copy our first query, which is Q1. I'll copy this and I'll paste it here. Let me just rename this now. This will be Q8, and I'll change this as well. I'll write select star from orders, where my order ID equal to 103. Let's see the unit price of 103 now. You can see here instead of 50, now we have updated it to $45. Alright, now the last command we are going to say is how you can delete a record from the table. I'll write delete command as my comment. Now to delete a query, I'll first give my variable name, which is delete underscore order, and I'll pass in within triple quotes. Next I'll write my delete query, which is delete from my table name, that is orders. Then I'll give my where clause, where let's say I want to delete my order ID 105. Let me just go to the top and explain you again. So if you say this, we want to delete the order ID 105, which was for customer name Maria, and she had ordered headphones. We want to completely remove this particular record. So I have my delete query ready. Now let me just create my connection and display the results. So I'll go to the top and I'll copy this connection command, which also has the execute query command, and I'll paste it here. And I'm going to make a change here. Instead of update, we'll write delete underscore order. Everything looks good. Let's just run it. You can see our query was successful. And now if you want to print it, let me just show you. I'll just copy this, we'll paste it here, I'll make this as Q9. I want to verify if my order ID 105 was deleted or not. Instead of this statement, I'll write select star from orders, and here I'll change this to Q9. If I run this, you can see it here. You can mark order ID 105 was deleted and it no more appears in this table. Alright, so this brings us to the end of the demo session on SQL with Python. Let me just scroll you through what we did. So first we imported the important libraries, MySQL connector, then we imported the error function, then we imported pandas using PD. We learned how to create a server connection to MySQL database. We created a new database, that is MySQL_Python, and now we connected to that database. We created a function to execute our queries. We saw how you can write a create table command. Then we inserted a few records to our orders table. We created a read_query command to read the queries and display the results. Then we started exploring our different SQL commands one by one. We saw how to use select query. Then we selected a few individual columns from our table, followed by using a inbuilt function which was year. Then we saw how to use the distinct keyword. After that, we used our where clause to filter our table based on specific conditions. We saw how to order your results based on a particular column. Then we saw how you could convert the table into a data frame using pd.dataframe function. Finally, we learned how to use the update command and the delete command.
So are you ready to get started with this amazing career? Check out postgraduate program in full stack web development by Simplilearn. So hurry up and enroll now. Find the complete course details from the link in the description box.
PostgreSQL is a very popular and widely used database in the industries. In this tutorial, we will learn PostgreSQL or PostgreSQL in detail with an extensive demo session. So let's begin by understanding what is PostgreSQL. PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebraker. In 1987, the first demo version was released, and in 1994, a SQL interpreter was added to Postgres. The first PostgreSQL release was known as version 6.0 or 6.0 on January 29, 1997, and since then, PostgreSQL has continued to be developed by the PostgreSQL Global Development Group, a diverse group of companies and many thousands of individual contributors. Now, let's look at some of the important features of PostgreSQL. So PostgreSQL is the world's most advanced open source database and is free to download. It is compatible as it supports multiple operating systems such as Windows, Linux and Mac OS. It is highly secure, robust and reliable. PostgreSQL supports multiple programming interfaces such as C, C++, Java and Python. PostgreSQL is compatible with various data types. It can work with primitives like integers, numeric, string and boolean. It supports structured data types such as date and time, array and range. It can also work with documents such as JSON and XML. And finally, PostgreSQL supports multi-version concurrency control or MVCC. Now with this theory knowledge, let's look at the PostgreSQL commands that we will be covering in the demo. So we will start with the basic commands such as select, update and delete. We will learn how to filter data using where clause and having clause in SQL. We will also look at how to group data using the group by clause and order the result using the order by clause. You will learn how to deal with null values, get an idea about the like operator, logical operators such as AND and OR. We will also explore some of the popular inbuilt mathematical and string functions. Finally, we will see some of the advanced concepts in PostgreSQL, that is, to write case statements, subqueries and user-defined functions. So let's head over to the demo now. Okay, so let's now start with our demo. So first we'll connect to PostgreSQL using PSQL cell. So here under type here to search, I'll search for PSQL. You can see this is the SQL cell. I'll click on open. Let me maximize this. Okay, so for server I'll just click enter. Database I'll click enter. Port number is already taken, which is 5432. I'll hit enter. Username is already given, and now it is going to ask for password. So here I'll give my password so that I can connect to my PostgreSQL database. So it has given us a warning, but we have successfully connected to PostgreSQL. Alright, so now to check if everything is fine, you can just run a simple command to check the version of PostgreSQL that we have loaded. So the command is select version with 2 brackets and a semicolon. I'll hit enter. Okay, you can see the version PostgreSQL 13.2. Okay, now let me show you the command that will help you display all the databases that are already there. So if I hit /L and hit enter, it will give me the list of databases that are already there. So we have PostgreSQL, there's something called template 0, template 1, and we have a test database as well. Okay, now for our demo, I'll create a new database. So first I'll write create space database, and I'll give my database name as SQL_demo. I'll give a semicolon and hit enter. You see we have a message here that says create database. So we have successfully created our SQL demo database. Now if you want to connect to that database, you can use \c space SQL_demo. There you go. It says you are now connected to database SQL_demo. So here we can now create tables, we can perform insert operation, select operation, update, delete, alter, and much more. Now I'll show you how to connect to PostgreSQL using pgadmin. So when you install the PostgreSQL database, you will get the SQL cell, and along with that you also have the pgadmin. So I'll just search for pg. You can see here it has prompted pgadmin. I'll click on open. This will open on a web browser. You can see it has opened on Chrome, and this is how the interface of pgadmin looks like. It is a very basic interface. So on the top you can see the files, we have object, there's tools, and we have the help section as well. And here you have dashboard, properties, SQL, statistics, dependencies, dependence, and here on the left panel you have servers. Let me just expand this so it will connect to one of the databases. Alright, so if I go back, you see when I had run \L to display the databases, it had shown me PostgreSQL and test. Now you can see here we have the PostgreSQL database and the test database. Alright, now we also created one more database, which was SQL demo. So let me show you how to work on this pgadmin and the query tool. Alright, so I'll right click on SQL demo and I'll select query tool. I'll just show you how to run a few commands on the query tool. So let's say you want to see the version of PostgreSQL that you are using, so you can use the same command that we did on PSQL cell, which is select version closed with brackets and a semicolon. I'll select this, and here you can see we have the execute button. So if I hit execute or press F5, it will run that query. You can see we have the output at the bottom, and it says PostgreSQL 13.2 compiled by Visual C++. It has the 64-bit system. Okay, now let me tell you how to perform a few basic operations using PostgreSQL commands. So here let's say I'll write select 5 into 3. I'll give a semicolon, select this and hit F5. So this will run the query and it returns me the result, that is the product of 5 and 3, which is 15. Similarly, let's edit this. Let's say I'll write 5 plus 3 plus, let's say, 6. I'll select this and hit F5 to run it. It gives me the sum of 5 plus 3 plus 6, which is 14. Now the same task you can do it on this cell as well. Let me show you how to do it here. So let's say I'll write select. Let's say I want to multiply 7 into, let's say, 10. You know the result, it should be 70. If I hit enter, it gives me 70. Now this question mark column question wall, will deal with this later. Alright, let me go back to my PG admin again. Let me do one more operation. Let's say this time I'll write select 5 multiplied by, and within brackets I'll write 3 plus 4. I'll give a semicolon. So what SQL will do is, first it will evaluate the expression that is there inside the bracket, that is 3 plus 4, which is 7, and then it will multiply 7 with 5. Now let me select this and I'll hit execute. So you can see 7 multiplied by 5 is 35. Alright, now we'll go back to our shell, and here I'll show you how to create a table. So we are going to create a table called movies on the cell, that is PSQL cell. So here we will learn how you can create a table and then you can enter a few data into that table. Alright, let me just scroll down a bit. Okay, so my create command goes something like this. So I'll write create table followed by the table name, that is movies. Next, my movies table will have a few columns. Let's say I want the movie ID. After the column name, we need to give the data type. So movie ID, I'll keep it as integer. So integer is one of the data types that is provided by PostgreSQL. Next, my second column in the table would be the name of the movie. So I'll write movie underscore name. So all the variables or the column names should be as per SQL standards, so there shouldn't be any space between the column names. So I have used underscore to make it more readable. So my movie name will be of type varchar or variable character or varying character, and I'll give the size as 40 so that it can hold 40 characters maximum. Next, my third column will have the genre of the movie. So I'll write movie underscore genre. Again, genre is of type varchar. I'll give the size as, let's say, 30. And my final and the last column will have the IMDb rating. So I'll write IMDb underscore ratings. Now the ratings will be of type real, since it can have floating or decimal point values. If I close the bracket, I'll give a semicolon and I'll hit enter. There you go. So we have successfully created a table called movies. Now let me go back to my PG admin. Alright, so here I have my database, that is SQL demo. I'll just right click on this and click on refresh. Now let me go to schemas. I'll just scroll down a bit. Here under schemas we have something called as tables. Let me expand this. Okay, so you can see we have a table called movies in the SQL demo database now, and here you can check the columns that we have just added. So our movies table has movie ID, movie name, genre and ratings. Alright, now there is another way to create a table. The previous time we created using the SQL cell. Now I'll tell you how to create a table using the PG admin. So here under tables, I'll right click and I have the option to create a table. So I'll select table. Okay, so it's asking me to give the name of the table. So this time we are going to create a table called students. So I'll write my table name as students. Alright, these will be default as it is. Now I'll go to the columns tab. So here you can create the number of columns that you want. So you can see on the right I have a plus sign. I'll just select this so that I can add a new row. So my first column would be, let's say, the student roll number. I'll write student underscore roll number. Again, the column name should be as per SQL standards. The data type I'm going to select is integer. Alright, now if you want, you can give these constraints such as not null, so that student roll number column will not have any null values. And I'll also check primary key, which means all the values will be unique for roll numbers. Alright, now if you want to add another column, you can just click on that plus sign, and let's say this time I want to give the student name as my second column. So I'll write student underscore name. Student name will be of type, let's say, character varying. If you want to give the length, you can specify the length as well, let's say 40. I'll click on the plus sign again to add my final column. The final column would be gender. So gender, I'll keep this time as type character. Okay, now you can click on save, so that will successfully create your students table. There you go. So here on the left panel you can see earlier we had only one table, that was movies, and now we have two tables. So one would be added, that was students. So if I expand this under columns, you can see we have the three columns here: student roll number, student name, and gender. You can also check the constraints. It will tell you if you have any constraints. So you can see it says students roll number, there's one primary key. Alright, now let me run a select statement to show the columns that we have in the movies table. So I'll write select star from movies, give a semicolon, and let me execute this. Okay, so here at the bottom you can see we have the movie ID, the movie name, movie genre, and IMDb ratings. Now the next command we are going to learn is how to delete a table. So there is one way by using the SQL command, that is drop table followed by the table name. Let's say you want to delete students. You can write drop table students, and that will delete the table from the database. This is one of the methods, so you just select and run it. Now the other way is to you just right click on the table name, and here you have delete / drop. If I select this, you get a prompt, are you sure you want to drop table students? I'll select yes. So you can see we have successfully deleted our students table. Alright, now let's perform a few operations and learn a few more commands in PostgreSQL. So to do that, I'm going to insert a few records to my movies table. So for that, I'll use my insert command. So I have my insert query written on a notepad. I'll just copy this and I'll paste it on my query editor. Okay, so let me just scroll down. Alright, so here you can see I have used my insert command. So I have written insert into the name of the table, that is movies, and we have the movie ID, the movie name, movie genre, and IMDb ratings, and these are the records or the rows. So we have the first record as movie ID 101. The name of the movie is a very popular movie, which is Vertigo. Then we have the movie genre, that is mystery. It is also a romance movie. And then we have the IMDb ratings, the current IMDb rating, that is 8.3. Similarly, we have Shawshank Redemption, we have 12 Angry Men, there's The Matrix, 7, Interstellar, and The Lion King. So there are total 8 records that we are going to insert into our movies table. So let me just select this and hit execute. Okay, you can see it has returned successfully 8 records. Now if I run select star from movies, you can see the records that are present in the table. So I'll write select star from movies, I'll select this and I'll execute it. There you go. At the bottom you can see 8 rows affected. If I scroll this down, you have the 8 records of information in the movies table. Alright, now if you want to describe the table, you can go to the SQL cell, and here if you write \d and the name of the table, that is movies, this will describe the table. So here you have the column names, this has the data type, and here you can specify if there are any null values or any constraints like default constraint or primary key or foreign key and others. Let me go back to my PG admin. Okay, now first and foremost, let me tell you how to update records in a table. So suppose you have an existing table and by mistake you have entered some wrong values and you want to update those records later. You can use the update query for that. So I'm going to update my movies table and I'll set the genre of movie ID 103, which is 12 Angry Men, from drama to drama and crime. So in our current table we only have genre as drama for 12 Angry Men. I am going to update this column, which is the movie genre, to drama and crime. Okay, so let me show you how to do it. I'll write update followed by the name of the table, that is movies. I'll go to the next line. I'll write set, then I'll give the column name, which is movie underscore genre, equal to, I'm going to set it as drama, comma, crime. Earlier it was only drama, and I'll give my condition using the where clause. We'll learn where clause in a bit. So I'll write where movie underscore ID is equal to 103. So here our movie ID is the unique identifier. So it will first look for movie ID 103. It will locate that movie and it'll change the genre to drama and crime. So now you can see the difference. Earlier we had 12 Angry Men as drama as the movie genre. Now if I run this update statement, okay, you can see we have successfully updated one record. Now let me run the select statement again. Okay, so here you can see if I scroll down, there you go. So movie ID 103, movie name 12 Angry Men, we have successfully updated the genre as drama, comma, crime. Okay, now let me tell you how you can delete records from a table. So for that you can use the delete command. So you'll write delete from the table name, that is movies, where, let's say I want to delete the movie ID 108, which is the Lion King. So I'll write where movie underscore ID is equal to 108. This is one of the ways to delete this particular movie, or you can give, let's say, where movie name is equal to the Lion King. Let me select this and I'll hit execute. Now if I run my select query again, you see this time it has returned 7 rows and you cannot find movie with movie ID 108, that was the Lion King. So we have deleted it. Alright, next we are going to learn about where clause in PostgreSQL. So to learn where clause, I'll be using the same movie table again. Let's say we want to filter only those records for which the IMDb ratings of the movies is greater than 8.7. So this is my updated table now. I want to display only those records or those movies whose IMDb ratings is greater than 8.7. So we'll display 12 Angry Men, which is 9. Then we are going to display The Dark Knight, which is again 9, and we are also going to display the Shawshank Redemption, which has 9.3. The rest of the movies have an IMDb rating less than 8.7, so we are not going to display those. Alright, so let me show you how to write a where clause. So I'll write select star from movies where I'll give my column name, that is IMDb underscore ratings is greater than, I'll use the greater than symbol, then I'll pass my value, that is 8.7. I'll give a semicolon and let's run it. I'll hit F5. There you go. So we have returned the Shawshank Redemption, The Dark Knight and 12 Angry Men, because only these movies had IMDb ratings greater than 8.7. Okay. Now let's say you want to return only those movies which have IMDb ratings between 8.5 and 9. So for that I am going to use another operator called between along with the where clause. So let me show you how to use between with where clause. I'll write select star from movies where my IMDb underscore ratings is between, I'll write 8.5, I'll give an AND operator, and 9.0. So all the movies that are between 8.5 and 9.0 ratings will be displayed. So let's select this and I'll run it. There you go. So we have returned The Dark Knight, The Matrix, The Seven, Interstellar, and we have the 12 Angry Men. So a few of the records that we missed out were, I think, Vertigo, which has 8.3, and there's one more. Alright. Now moving ahead, let's say you want to display the movies whose movie genre is action. You can see in our table we have a few movies whose genre is action movie. So you can do that as well. I'll write select star from movies where the movie genre, I'm writing this time in one line. You can break it into two lines as well. I'll write movie underscore genre, which is my column name, equal to, I'll give within single quotes action. Now why single quote? Because action is a string, hence we need to put it in single quotes. If I run this, there you go. So we had one movie in our table whose movie genre was action, that is The Dark Knight. Okay. Now you can also select particular columns from the table by specifying the column names. Now here in all the examples that we saw just now, we are using star. Now star represents, it will select all the columns in the table. If you want to select specific columns in the table, you can use the column names. So you can specify the column names in the select statement. Let me show you. Let's say you want to display the movie name and the movie genre from the table. So you can write select movie underscore name, comma, I'll give the next column as movie underscore genre from my table name, that is movies where, let's say, the IMDb underscore ratings is less than 9.0. So this time in our result it will only show two columns, that is movie name and movie genre. Let me run it. There you go. So these are the movie names and the movie genres you can see that have an IMDb ratings less than 9.0. Alright. Like how you saw the between operator, there is one more operator that you can use with the where clause, that is the in operator. So the in operator works like a or clause or an or operator. So let's say I want to select all the columns from my movies table where the IMDb ratings is in 8.7 or 9.0. If I run this, it will display only those records whose IMDb ratings is 8.7 or 9.0. Alright, so up to now we have looked at how you can work on basic operations in SQL like your mathematical operations. You saw how a select statement works. We created a few tables, then we inserted a few records to our tables. We saw how you can delete a table from your database, and we have performed a few operations like update, delete, and we saw how a where clause works. Now it's time to load a employee CSV file or a CSV dataset to PostgreSQL. So I'll tell you how you can do that. But first of all, before loading or inserting the records, we need to create an employee table. So let me first go ahead and create a new table called employees in our SQL_demo database. So I'll write create table. My name of the table would be employees. Next, I'm going to give my column names. So my first column would be employee ID. So the employee ID will be of type integer. It is not going to contain any null values, so I'll write not null, and I'll give my constraint as primary key. So the employee ID, as you know, is unique for all the employees in a company. So once I write primary key, it will ensure that there are no repetition in the employee IDs. Okay. Next, I'll have my employee name. So my employee name is going to be of type varchar, and I'll give my size as 40. Okay. Next, we'll have the email address of the employee. Again, email address would be of type varchar and the size is 40 again. I'll give another comma. This time we'll have the gender of the employee. Gender is again varchar of size, let's say 10. Okay. Now let's include a few more columns. We'll have the department column. So I'll write department varchar. Let's say the size is 40. Then let's say we'll have another column that is called address. So the address column will have the country names of the employees. Address is also varchar. And finally we have the salary of the employee. Salary, I'm going to keep it as type real. So real will ensure it will have decimal or floating point values. Okay, so now let me select this create table statement and execute it. Alright, so we have successfully created our table. If you want, you can check by using select star from employees. Let me select this and I'll hit execute. Alright, you can see we have our employee ID as primary key. There's employee name, email, gender, there's department, address and salary. But we don't have any records for each of these columns. Now it's time for us to insert a few records to our employees table. Now to do that, I'm going to use a CSV file. So let me show you how the CSV file looks like. Okay, so now I am on my Microsoft Excel sheet, and on the top you can see this is my employee data.csv file. Here we have the employee ID, the employee name, email, gender, there's department, address and salary. Now this data was generated using a simulator, so this is not validated, and you can see it has a few missing values. So under email column we have a few employees who don't have an email ID. Then you can see under department also there are some missing values here as well. Alright, so we'll be importing this table or the records present in this CSV file onto PostgreSQL. Alright, so here in the left panel under tables, let me right click and first refresh this. There you go. So initially we had only movies table, and now we also have the employees table. Now what we need to do is I'll right click again, and here you see we have the option to import or export. Let me click on this. and I don't want to export, I need to import, so I'll switch on import. Alright, now it is asking me to give the file location. So let me show you how to get the file location. So this is my file location actually. So my Excel file, which was this, is present in my E drive under the data analytics folder. I have another folder called PostgreSQL, and within the PostgreSQL folder I have my CSV file, that is employee data.csv. So I'll just select this. You can either do it like this or you can browse and do. Okay, now my format is CSV. Next, I'm going to select my headers as yes, and then let me go to columns and check if everything is fine. Alright, so I have all my columns here. Let's click on OK. You can see I have a message here which says import underscore export. Alright, so here you can see successfully completed. We can verify this by using select star from employees again. If I run this, alright, let me close this. There you go, it says 150 rows affected, which means we have inserted 150 rows of information to our employees table. You can see we have the employee ID, these are all unique. We have the employee name, the email, we have the address and the salary. Let me scroll down so that, okay, you can see we have 150 rows of information. That means we have 150 employees in our table. Okay, now we are going to use this employees table and explore some advanced SQL commands. Now there is an operator called distinct. So say if I write select address from employees, this is going to give me 150 address of all the employees. There's some problem here, I did a spelling mistake. There should be another D. If I run this again, our query will return 150 rows. You can see we have the different country names under address, that is Russia, we have France, there's United States, we have Germany, okay, and I think we have Israel as well. Yeah. Now suppose you want to display only the unique address or the country names, you can use the distinct keyword before the column name. So if I write select distinct address from employee, it will only display the unique country names present in the address column. If I run this, see, it has returned us 6 rows of information. So we have Israel, Russia, Australia, United States, France and Germany. Alright, now as I said, there are a few null values which don't have any information. So you can use the isNull operator in SQL to display all the null values that are there. Suppose I want to display all the employee names where the email ID has a null value. So I'll write select star from employees where email is null. So this is another way to use your where clause. If I select and run this, there you go. So you see here, for all these employee names, there was no email ID present in the table. So it has returned us 16 rows of information. So around 10% of employees do not have an email ID, and if you see, a few of them do not have an email ID and also they don't have a department. So if you want to know for those employees which do not have a department, you can just replace where department is null instead of where email is null. Now if I select this, okay, it has returned us 9 rows of information, which means around 5% of employees do not have a department. Moving ahead, now let me show you how the order by clause works in SQL. Now the order by is used to order your result in a particular format, let's say in ascending or descending order. So the way to use is, let's say I want to select all the employees from my table, so I'll write select star from employees order by, I want to order the employees based on their salary. So I'll write order by salary. Let me select and run it. Okay, there is some problem. I made a spelling mistake. This should be employees. Let me run it again. Okay, now if you mark the output, our result has been ordered in ascending order. So all the employees which have salary greater than $45,000 appear at the top, and the employees with the highest salaries appear at the bottom. So this has been ordered in ascending order, which means your SQL or PostgreSQL orders it in ascending order by default. Now let's say you want to display the salaries in descending order so that all the top ranking employees in terms of salary appear at the top. So you can use the DESC keyword, which means descending. If I run this, you can see the difference now. So all the employees with the highest salary appear at the top, while those with the lowest salaries appear at the bottom. So this is how you can use an order by clause. Okay, so now I want to make a change in my existing table. So here if you see, under the address column we only have the country names. So it would be better if we change the name of the address column to country. So I want to rename a column. You can do this using the alter command in PostgreSQL. So let me show you how to rename this column, that is address. So I'll write alter table followed by the table name, which is employees. Then I'm going to use rename column address. I'll write to, I want to change it to country. If I give a semicolon and hit execute, it will change my column name to country. Now you can verify this. If I run the select statement again, there you go. Earlier it was address column and now we have successfully changed it to country column. Okay, let me come down. Now it's time for us to explore a few more commands. So this time I'm going to tell you how an AND and an OR operator works in SQL. So you can use the AND and OR operator along with the where clause. So let's say I want to select the employees who are from France and their salary is less than $80,000. So let me show you how to do it. I'll write select star from employees where I'm going to give two conditions. So I'll use the AND clause or the AND operator here. I'll write where country is equal to France. Now mark here, I'm not using address because we just updated our table and changed the column name from address to country. So I'll write country equal to France, and my next condition would be my salary needs to be less than $80,000. I'll give a semicolon. Let me run this. Alright, so it has returned 19 rows of information. You can see all my country names are France and the salary is less than $80,000. So this is how you can use or give multiple conditions in a where clause using the AND operator. Now let's say you want to use the OR operator, and let's say you want to know the employees who are from country Germany, or the department should be sales. So I'll write select star from employees where country is equal to Germany, and instead of AND I'm going to use OR. Their department should be sales. Okay, now let's see the output. I'll hit F5 this time to run it. Alright, so we have 23 rows of information now. Let me scroll to the right. You can see either the country is Germany or the department is sales. You see one of them in the table. So here for the first record the country was Germany, the second record the department was sales, again for the fourth record the country is Germany. So this is how the OR condition works. So if one of the conditions are true, it will return the result. It need not be that both the conditions should satisfy. Now in PostgreSQL there is another feature that is called limit. So PostgreSQL limit is an optional clause on the select statement. Now this is used as a constraint which will restrict the number of rows returned by the query. Suppose you want to display the top 5 rows in a table, you can use the limit operator. Suppose you want to skip the first 5 rows of information and then you want to display the next 5, you can do that using limit and offset. So let's explore how limit and offset works. I'll write select star from employees. Let's say I'll use my order by clause. I'll write order by salary, let's say in descending, and limit it to 5. This is going to display the top 5 employees which have the highest salary. If I run this, there you go. You see it has given us 5 rows of information and these are the top 5 employees that have the highest salary. Okay, so this is one method of or one way of using the limit clause. Now in case you want to skip a number of rows before returning the result, you can use offset clause placed before the limit clause. So I'll write select star from employees, let's say order by salary, descending. This time I'm going to use limit 5 and offset 3. So what this query will do is it will skip the first 3 rows and then it will print the next 5 rows. If I run this, there you go. So this is how the result looks like. Okay. Now there is another clause which is called fetch. Let me show you how that works. I'll copy my previous SQL query. I'll paste it here. And here after descending, I'm going to write fetch first 3 row only. So my fetch is going to give me the first 3 rows from the top. There you go. It has given us the first 3 rows and you can see the top 3 employees that have the highest salary since we ordered it in descending order of salary. Alright. You can also use the offset along with the fetch clause. I'll copy this again and let me paste it here. Now after descending, I am going to write offset, let's say 3 rows, and fetch first 5 rows only. So what this SQL query is going to do is it will skip the first 3 rows of information and then it is going to display the next 5 rows. It is going to work exactly the same as we saw for this query. Let me run it. There you go. So these are the first 5 rows of information after excluding the top 3 rows. Alright. We have another operator that is called as like in PostgreSQL. So like is used to do pattern matching. So suppose you have a table that has the employee names. You forgot the full name of an employee but you remember the few initials. So you can use the like operator to get an idea as to which employee name it is. Now let's explore some examples to learn how the like operator works in PostgreSQL. So suppose you want to know the employees whose name starts with A So for that you can use the like operator. Let me show you how to do it. So I want to display the employee name, and let's say I want to know their email IDs from the table name, that is employee, where since I want to know the employees whose name starts with A, so I'll write employee name like. Now to use the pattern is within single quotes I'll write A and then followed by percentage. Now this means the employee name should have an A in the beginning, and percentage suggests it can have any other letter following A, but in the beginning or the starting should be A. If I run this, so there is an error here. The name of the table is employees and not employee. Let's run this again. There you go. You can see there are 16 employees in our table whose name starts with A. You can see this column employee name, all of them have a letter A in the beginning. Okay, now let me just copy this command or the query. I'll paste it here. Let's say this time you want to know the employees whose name starts with S. So instead of A, I'll write S. So this means the starting letter should be S and followed by it can have any other letter. If I run this, so there are 10 employees in the table whose name starts with S. Okay, let's copy the query again, and this time I want to know the employees whose name ends with D. Now the way to do it is instead of a percentage, I'll write this time percentage D, which means at the beginning it can have any letter, but the last letter in the string or in the name should be ending with D. Now let me copy and run this. So there are 13 employees in the table whose name ends with a D. You can see it here. Alright, now let's say you want to find the employees whose name contains ISH or have ISH in their names. So the way to do is something like this. So I'll copy this. Now here instead of a percentage, I'll replace this with percentage ISH percentage. Now this means that in the beginning it can have any letter and towards the end also it can have any letter, but this ISH should appear within the name. Let me run and show it to you. Okay, so there is one employee whose name contains ISH. You can see here there is an ISH in the last name of the employee. Alright, now suppose you want to find the employee name which has U as the second letter. It can have any letter in the beginning, but the second letter of the employee name should have U. Now the way to do is I'll copy this, and instead of a%, I'll write underscore U followed by %. Now this underscore, you can think of a blank that can take any one letter. So the beginning can start with A, B, C, D or any of the 26 alphabets we have. Then it should contain U as the second letter followed by any other letter or letters. Let me run this. Okay, so there are 10 employees in the table whose name has a U as the second letter. You can see these. Okay, now moving ahead, let me show you how you can use basic SQL functions or inbuilt functions. So we'll explore a few mathematical functions now. So let's say you want to find the total sum of salary for all the employees. So for that you can use the sum function that is available in SQL. So I'll write sum, and inside the sum function I'll give my column name that is salary from my table name that is employees. Let's see the result. This will return one unique value. There you go. Now this is the total salary. Since the value is very large, it has given in terms of E. Now one thing to note here is, if you see the output, the column says sum real. So this output column is not really readable. So SQL has a method which can fix this, that is called an alias. So since we are doing an operation of summing the salary column, we can give an alias to this operation by using the as keyword. So if I write sum of salary as, let's say, total salary, then this becomes my output column. You can see the difference if I run this. Okay, you can see now in the output we have the total salary. Now this is much more readable than the previous one. So this is a feature in Excel where you can use or give alias names to your columns or your results. Now similarly, let's say you want to find the average of salary for all the employees. Now SQL has a function called AVG which calculates the mean or the average salary. If I write AVG and I can edit my alias name as well, let's see, I'll write mean salary. Let's run it. You can see the average salary for all the employees. It's around $81,000. Okay, now there are two more important functions that SQL provides us, which is max and minimum. So if I write select maximum or max, which is the function name of salary, as let's say instead of total I'll write maximum, so this will return me the maximum salary of the employee. Let's run it and see what is the maximum salary that is present in the salary column. Alright, so we have $1,19,616 as highest salary of one of the employees. Similarly, you can use the min function as well. I'll just write minimum and this will return me the minimum salary of one of the employees in the table. I'll replace the alias name as minimum. Okay, now run it. This will give me the minimum salary that is present in our table. So it is $45,685. Okay, now let's say you want to find the count of department in the employees table. You can use the count function. So if I write select count, let's say I want to know the distinct department names, I can write inside the count function distinct department as total departments from employees. Let's run this. This will return me the total number of departments that are there. So it gives me there are 12 departments. Okay, now let me show you one more thing here. If I write select department from employees, let's run this. Okay, so it has returned me 150 rows of information, but what I'm going to do is I'll place my distinct keyword here just before the column name so that I can verify how many departments are there in total. There you go. So there are 13 departments and one of them is null. So moving ahead, we'll replace this null with a department name by updating our table. Okay, so now let's update our department column. So what we are going to do is wherever the department has a null value, we are going to assign a new department called analytics. So earlier we have also learned how to use the update command, so I'm going to show it again. So we'll write update followed by the table name, that is employees. I'm going to set my column, that is department, equal to, within single quotes, my name of the department would be analytics, where department is, I'll say null. So wherever the department has a null value, we'll replace those information with department, that is analytics. Let's run this. You can see query returned successfully. Now let's say I'll run this command again, and this time you can see the difference. There you go. So we have 13 rows of information and there is no null department now. We have added a new department, that is analytics. Okay, now we are going to explore two more crucial commands or clauses in SQL, that is group by and having. So let's learn how group by clause works in PostgreSQL. So the group by statement groups rows that have the same values into summary rows. For example, you can find the average salary of employees in each country or city or department. So the group by clause is used in collaboration with the select statement to arrange identical data into groups. So suppose you want to find the average salary of the employees based on countries, you can use the group by clause. So let me show you how to do it. I'll write select. I want the countries and the average salary for each country. So I'll use the average function, that is avg, and inside the function I'll pass my column, that is salary. I'll give an alias name as, let's say, average underscore salary from my table name, that is employees. Next I'm going to use my group by clause. So I'll write group by. Since I want to find the average salary for each country, so I'll write group by country name. Let's give a semicolon and let me run it. I'll use F5. There you go. So here on the left you can see the country names. We have Israel, Russia, Australia, United States, France and Germany, and on the right, the second column, you can see the average salary for each of these countries. Now you can also order the result in whichever way you want. Suppose you want to arrange the results based on the average salary, so you can use the order by clause after the group by clause. So I'll write order by. Here you can use the alias name, that is average salary. This is actually average underscore salary, and let's say I want to arrange it in descending order, so I'll write DESC. Now let's run this. You can mark the difference in the average salary column. There you go. So as per our result, in United States the average salary is the highest, and if I scroll down, the average salary is the lowest in Germany. Now let's see one more example using group by. Suppose this time you want to find the maximum salary of male and female employees. You can do that too. So let me show you how to do it. So I'll write select. This time we want to find the maximum salary based on gender. So I'll select my gender column, comma, and this time I'll use my max function. Since I want to find the maximum salary for male and female employees, I'll give an alias name as maximum underscore salary from my table, that is employees. Group by, I'll write gender. Okay, so let's run this. There you go. You can see, so one of the female employees had a highest salary of $1,19,616, while of that of a male was $1,17,654. Alright, now suppose you want to find the count of employees based on each country. You can use the count function along with the group by clause. So I'll write the select statement, select. Since I want to count the employees based on each country, so I'll first select my country column and then I'm going to use the count function. I'll write count emp underscore id from my table name, that is employees. I'm going to group it by country. So this query will give me the total number of employees from each country. You can see here Israel there are 4 employees, in Australia there are 4 employees, in Russia we have 80 employees, in France there were 31, in United States we have 27, so on and so forth. Now let me scroll down. Okay, now it's time to explore one more clause, a very important clause that is used in PostgreSQL, that is having. So the having clause works like the where clause. The difference is that where clause cannot be used with aggregate functions. The having clause is used with the group by clause to return those rows that meet a condition. So suppose you want to find the countries in which the average salary is greater than $80,000. So you can use the group by clause and the having clause to get the result. So I'll write my select statement as select country, comma, I want the average salary. So I'll write AVG of salary. I can give an alias name as average salary from employees. Now I'm going to group it by each country. So group by country column. Since I want to find the countries in which the average salary is greater than 80,000, so I'll use having clause after the group by clause. I'll write having average of salary is greater than 80,000. Now this condition cannot be specified in the where clause, so we need a having clause. You cannot use aggregate functions along with where clause. Let me just run it now. There you go. So we have Russia and United States where the average salary is greater than $80,000. Alright. Now let's say you want to find the count of employees in each country where there are less than 30 employees. So for this I am going to use the count function. First let me select the country column. Then I'm going to use the count function, and in the count function I'm going to pass my employee ID so that we can count the number of employees from my table, that is employees. Now if you want you can use an alias name for this as well, but I am just skipping it for the time being. I'll write group by country. Next I'll write having count of employee ID less than 30. So this will return me the countries in which there are less than 30 employees. Let's run it. You can see here Israel, Australia, United States and Germany are the countries in which there are less than 30 employees. Okay, now if you want you can use the order by clause as well. So suppose I'll write here order by count of employee ID. So what this will do is it will arrange my result in ascending order of employee ID count. There you can see we have successfully arranged our result in ascending order of employee IDs. Okay, next we are going to explore one more feature of PostgreSQL, that is of using a case statement. Now in PostgreSQL the case expression is same as if-else statement in any other programming language. It allows you to add if-else logic to the query to form a powerful query. Now let me just scroll down and I'll show you how to use a case statement. This is very similar to your if-else statement that you use on Excel, in C++, in Python or any other programming language. So what I'm going to do is I'm going to write a SQL query that will create a new column, and the name of the column would be, let's say, salary range. So I'm going to divide my salary. Suppose if the salary is greater than $45,000 and if it's less than $55,000, in the new column, that is salary range, we are going to assign a value low salary. Now if the salary is greater than $55,000 and if it is less than $80,000, we are going to assign a value that is medium salary. If the salary is greater than $80,000, we'll assign a value high salary. So all this we are going to do using our case expression in PostgreSQL. So I'll start with my select statement, but before that let me show you how to write a comment in PostgreSQL. So you can write a comment by giving a double dash Comments are very helpful because they make your codes or the scripts readable. I'll write case expression in PostgreSQL. Similarly, if you want, you can go to the top and let's say here you can write with double dash having clause. Okay, let's come down. So I'll write my select statement as select. I want the department, the country and the salary column. I'll give a comma and I'll start with my case statement. I'll write case when my salary is greater than 45,000 and my salary is less than 55,000, then the result would be, within single quotes, I'll write low salary. So this is exactly like an if-else condition. Next, I'll write another case when salary is greater than 55,000 and salary is less than, let's say, 80,000, then the result would be medium salary. And finally, I'll give my last condition, that is when salary is greater than 80,000, then the result will be high salary. Let me write this in a single line, then high salary. Now one thing to remember, in PostgreSQL the quotes are insensitive, so you can write your select statement in capital, in lowercase or in sentence case. Similarly, I can write case as small c or you can write as capital C. Alright, now moving ahead, after this I am going to write end. I'll give an alias name as salary range. Now this is going to be my new column in the output. Let me just come down. After this we need to give our table name from employees. I'll order it by salary descending. Okay, so what I'm going to do here is I'll first select department, country and salary column from my employees table, and then I'm creating a new column, that is salary range, and I'm specifying the range. So I have three conditions here, for low salary, for medium salary and high salary. So let's run this and see the output. There you go. Here you can see we have added a new column known as salary range, and we have order our salary in descending order, so all the highest salaries appear at the top. If I just scroll down, you can see we have medium salaries here, and if I scroll down further, you can see these low salaries. So case statements are really useful when you want to create a new column based on some conditions in the existing table. Alright, now moving ahead, we are now going to see how to write subqueries in PostgreSQL. So subqueries, we write a query inside another query, which is also known as nested query. So suppose we want to find the employee name, department, country and salary of those employees whose salary is greater than the average salary. So in such cases you can use subqueries. Now let me show you how to write a query inside another query. First I'll write the select statement. I am going to select the employee name, comma, I want the department, comma, I also want to display the country name and the salary from the employees table, where my salary should be greater than the average salary. So after this where salary greater than, I am going to use brackets and write my subquery, that is select average salary from employees. Now let me break it down for you. So first we are going to select the average salary from the employees. So this particular SQL statement will find the average salary from the table. We'll compare this average salary with salaries of all the employees. So whichever employee has the salary greater than the average salary will display their names, the department, country, and their original salary. So if you want, you can run this statement as well. Let me select this statement and run it for you. You can see we have written the average salary of all the employees, which is nearly $81,466. So we want the salaries of the employees to be greater than this average value. So let me run this and see how many employees have a salary greater than the average salary. There you go. So we have around 75 employees whose average salary or whose salary is greater than the average salary. Alright. Now moving ahead, this time I'm going to tell you how to use some inbuilt functions. We'll learn some inbuilt mathematical functions and string functions that are available in PostgreSQL. So I'll just give a comment. There's another way to write a comment. Instead of a double dash, you can use the forward slash, an asterisk, and inside the asterisk you can write, let's say, SQL functions, and you need to close this. So I'll give another asterisk and a forward slash. So this is also a comment in PostgreSQL. Alright, so first of all we'll explore a few math functions. So there is a function called ABS which is used to find the absolute of a value. So if I write select ABS of, let's say, -100, it is going to return me positive 100 or just 100, because as you know, the absolute of any value will remove the negative sign involved in that value. There you go. So our original input was -100, the absolute of -100 is +100. Next, let's see another function that is called greatest. So the greatest function in PostgreSQL will return the greatest number in a range of numbers. So suppose I write select greatest. Inside the greatest function, I'll pass in a few numbers, let's say 2. I'm just randomly passing a few numbers, let's say 490, let's say 56.5, and let's say 70. I'll give a semicolon. Let me run this. You will see the greatest function will return the greatest integer value or greatest number that is present in the range of numbers that we have provided. So in this case 90 was the largest number or the greatest number, so we got the result as 90. Again, you can use an alias for each of these statements. Now like greatest, we also have a function called least which is going to return the least number present in a range of numbers. If I run this, so the result is 2 because 2 is the least number that is present in this selection. Alright, now there's a function called mod which is going to return the remainder of a division. So suppose I write select mod, and this takes two parameters, let's say 54 divided by 10. As you can guess, the remainder is 4, and so is our result. You can see it has returned the remainder 54 divided by 10, the remainder is 4. Alright, if I scroll down, now let's see how to use the power function. So I'll write select power, let's say I want to know power 2, 3, which is 2 cube, that is 8. Let me just run this. There you go. So the result is 8. You can also check, let's say, power of 5, 3, it should be 125. Alright. Next, You can use the sqrt function that is available in PostgreSQL to find the square root of a number. I'll write sqrt, and let's say I want to find the square root of 100. You can guess the result. The output should be 10. If I run this, you can see the output here 10. Let's say I want to find the square root of, let's say, 144. You can again guess the result. It should be 12. Let's verify it. Okay, there is some error. Let me verify it again. There you go. It is 12. Now, there are a few trigonometric functions as well. You can use the sine function, the cos function, and the tan function. Let's say I want to know the sine of 0. If you have studied high school mathematics, you would know the sine of 0 is 0. You can see the result, it is 0. Let's say you want to know sine 90. If I run it, you can see the output here, 0.89. Alright. Now there are other functions like ceiling and floor that you can use. So let me show you what the ceiling and floor function does. I'll write ceiling. Let's say I'll pass my floating value as 6.45 and let me run it. You can see the ceiling function returns the next highest integer, that is 7 in this case, since the next highest integer after 6.45 is 7. Let's see what the floor function does, and let me run it. As you can see, the floor function returns the next lowest integer, that is 6 in this case, or the nearest lowest integer to any provided decimal value. Okay. Now that we saw how to use mathematical functions, there are a few string functions available in PostgreSQL. So let's explore them as well. I'll write string functions. Okay. We'll scroll down. Cool. There's a function called character length that gives you the length of a text string. Suppose I write select, give the function as character length, and inside this function I'm going to pass in a text. Let's say India is a democracy. This is my text. Let me run this. Okay, you can see the result here, which is 20, since there are 20 characters in my string that I have provided. Alright. Now there's another function called concat in PostgreSQL. So concat is basically used to merge or combine multiple strings. So I'll write select concat, within brackets I'll give the text string now. Let's say I want to combine PostgreSQL I'll give a space, comma, I want to merge PostgreSQL is, I'll give another comma and write my final word, that is interesting. Now what we have done is, inside the concat function we have passed in separate strings, and now using the concat function we want to merge the three strings. Let's see what the result is. I'll run it. Alright, let me just expand this. You can see here we have concatenated the three strings successfully, so the output is PostgreSQL is interesting. Okay. Now there are functions like left, right, and mid in PostgreSQL. So what the left function does is, it will extract the number of characters that you specify from the left of a string. Let's say I'll write select left, and I'll pass in my text string as India is a democracy. I'll copy this and I'll paste it here. Let's say I want to extract the first 5 characters from my string, so I'll give 5. So what it will do is, it will count 5 characters from left, so 1, 2, 3, 4 and 5. If I run this, it should ideally print India for me. There you go, it has printed India for us. Alright, similarly you can use the write function to extract few characters from the right of a string. Let's say you want to extract, let's say I'll give 12 characters from right, so from here onwards it will count 12 characters. I'll change left to right now. Let me select this and run it. So you can see here, this is the output. From the right it has counted 12 characters and returned a democracy. Okay, now there is a function called repeat. So the repeat function is going to repeat a particular string the number of times you specify. Let's say I want to select and use my repeat function, and inside the repeat function I'm going to pass in, let's say, India, and I want India to be displayed 5 times. I'll give a semicolon and run it. In the output you can see India has been printed 5 times. Okay, let's scroll down. There is another function, a string function in PostgreSQL called as reverse. So what reverse function is going to do is, it is going to print any string passed as an input in reverse order. So if I write select reverse, and inside the reverse function I'll pass in my string, that is India is a democracy. I'm going to use the same string. I'll copy this and I'll paste it here. I'll close the quotes and the brackets. Let's print this. You can see it here, India is a democracy has been printed in reverse order. There you go. Alright, now this time we explored a few inbuilt functions that are already present in PostgreSQL. Now PostgreSQL also has the feature where you can write your own user-defined functions. So now we will learn how to write a function of our own in PostgreSQL. So let's create a function to count the total number of email IDs that are present in our employees table. So for this we'll write a function, a user-defined function. So let me give my comment as user-defined function. Okay, so let me start by first writing create. So this is the syntax to write a function in PostgreSQL. So I'll write create or replace function, then I'll give my function name as count emails, and as you know, functions have brackets. Then I'll write returns, the return type, as integer, then an alias with dollar symbol. I'll write total emails, since I'm going to display the total number of email IDs that are present in my table. I'll close the dollar symbol. Then I'm going to declare a variable. The variable name is going to be total underscore emails. This is of type integer. I'll write begin, and inside begin I'll write my select statement. So I'll write select, I want to count the email IDs that are present, so I'll pass my column name, that is email, into total emails from my table name, that is employees. I'll give a semicolon, and then we'll write return total emails. As you know, user-defined functions often return a value, so hence we have mentioned the return statement as well. And now I'm going to end my function. Then the next syntax would be, let me just scroll down, Okay, so here I'll give my dollar symbol again, followed by total underscore emails. Next, I'll write my language PostgreSQL. So the way to mention is PLPG Let's give a semicolon and end it. So this is my user defined function that I have written. So I created a function with the function name count underscore emails, and this would return integer as an alias which is total underscore emails. We declared that variable as an integer. Then we started with a begin statement that has my select statement where I am selecting the count of email IDs that are present in the employees table, and I am putting the value into total underscore email. So I have used the into keyword, and this returns the result as total underscore emails, and I have ended. Let's run this. Okay, there is some problem. There is an typo, so this should be integer. Okay, let me run it once again. There you go. So you've successfully created a user defined function. Now the final step is to call that function. Now to call this function, I'm going to use my select statement and the function name, that is count underscore emails. I'll give a semicolon. Let's execute this. There you go. So here you can see there are 134 email IDs present in our employees table. Now one thing to mark is there are total 150 employees in the table, but out of them 134 employees have email IDs, the rest of them don't have, so they would ideally have null values. Alright, so that brings us to the end of this demo session on PostgreSQL tutorial. Let me go to the top. We have explored a lot. So we started with checking the version of PostgreSQL. Then we saw how to perform basic mathematical operation, that is to add, subtract, multiply. Then we saw how to create a table that was movies. We inserted a few records to our movies table. Then we used our select clause. We updated a few values. Then we deleted one row of information. Then we learned how to use the where clause. We learned how to use the between operator. We also learned how to use the in operator. Let me scroll down. We created a table called employees, and then we learned how the distinct keyword works. We also learned how to use isNull with where clause. We learned about the order by clause. We saw how to alter or rename a column. Then we explored a few more examples on where clause, where we learned about and OR operator. Then we learned how to use limit and offset, as well as the fetch operator or the fetch keyword in PostgreSQL. Moving further, we learned about the like operator in SQL, which was used to perform pattern recognition or pattern matching, you can say. Here we saw how to use basic inbuilt PostgreSQL functions like sum, average, minimum, count, maximum. Next, we saw how to update a value in a column using PostgreSQL update command. We learned how to use group by. Then we learned how to use having clause. Then we learned how to use case expressions in PostgreSQL. So we saw how case expression is similar to our if else in any other programming language. We explored a few mathematical and string functions, and finally we wrote our own user defined function. So that brings us to the end of this tutorial on PostgreSQL. Now if you want to get this SQL file that we have used in the demo, you can give your email IDs in the comment section, and our team will share this SQL file with you over email.
In this session, we will learn who is a SQL developer and what are their responsibilities in a company. Then we will focus on the skills required to become a successful SQL developer. We will see the expected average salary in both US and India. We will also discuss how to become a SQL developer and look at the top companies hiring for SQL developers. So hey everyone, I'm Abhisar Ahuja from Simplilearn and welcome to this video on how to become a SQL developer. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. When going through some of the popular job boards online, you would easily see SQL developer is one of the most demanding jobs sought by companies. As we all know today, companies collect vast volumes of data and store it in their own databases. They want professionals with a good understanding of data who can keep it safe and secure. So, first we will understand who is a SQL developer. SQL developer is a person who is accountable in creating and managing huge data assets of a company. In other terms, SQL developer is a person who can develop SQL databases as well as write and test code. Let's understand this with the help of an example. Let's say we want to search a particular product on Amazon website and Amazon has stored all its data about products in a database. Now we will write the product name in the search bar, and when we click on the search button, it will run a SQL query that fetches all the information about the product and displays us on the website. So this is the basic task done by a SQL developer. Now we will understand the responsibilities of a SQL developer. All databases have a structure and logic behind how data is stored and retrieved. A SQL developer designs the database accordingly for businesses, that is called database modeling. After the database is created and deployed, it's the SQL developer who is responsible for fixing the general issues of the database. SQL developer should be well versed with structured query language to create optimized SQL queries and refines the existing ones to extract information from the database. SQL developers run several diagnostic tests to keep a check on the server and the database. In order to understand how to organize companies' data, SQL developers must communicate with technical and non-technical persons from the business, and SQL developer also gathers client requirements and identifies the features that the database owners want. As data is an asset to a company, SQL developers backup and restore data for their clients. They also perform tasks like data management and data migration. That is, if a company has stored all its data on a local storage and now it wants its data to be stored in a cloud storage. So the safe transmission of the data from local storage to cloud storage is known as data migration, and that is done by the SQL developers. After knowing the responsibilities, now we should look for skill set required to be a good SQL developer. One should have a good knowledge of SQL commands, functions, joins and procedures. Let's have a look at few commands such as create, drop, alter and truncate. These commands come under data definition language. We also have insert, update and delete commands. These commands come under data manipulation language. We have grant and revoke commands. These commands come under data control language. We also have commit, rollback and save point commands. These come under transaction control language. These are the basic commands a SQL developer should be familiar with. And a SQL developer may have a little command on any one programming language. You don't have to be expert in programming. All you need is how to interface between application and your database. For example, you are using MySQL and your web application is based on PHP. Then you should know how to connect your application to the database and how to issue queries, how to fetch results and then how to display it to the users. One should have a good understanding of various database management systems such as MySQL, Microsoft Access, Oracle, PostgreSQL, DBase, FoxPro, SQLite, IBM DB2, LibreOffice Base, MariaDB, and Microsoft SQL Server. One should know integration of databases with data visualization software such as Power BI and Tableau, which helps businesses to make better decisions and give you an add-on as a SQL developer. One should develop critical thinking and problem-solving skills to create optimized queries. Now we'll see how a SQL developer is compensated in both United States and India. In the United States, SQL developers draw an average salary of $72,282 per annum. In India, the average salary of a SQL developer is rupees 4,49,532. Now we'll see how a person can become a good SQL developer. For that, one should have a good command on structured query language and know how to interact with database management system and can issue queries to get the desired result. Earning industry recognized SQL developer certifications such as Microsoft Certified Professional Developer MCPD or Oracle PL/SQL Developer Certified Associate, which usually require a passing score on an exam. And it's important to accumulate as much practical experience as possible. Start by designing, creating, and querying small databases connected with your hobbies and interests. For example, your favorite music, videos, or your personal finances. This will enable you to gain experience, test your knowledge, and build your project portfolio, which will be highly beneficial when you start applying for your first full-time position. Now we will see some major companies recruiting SQL developers. First we have the multinational financial services corporation American Express, followed by the multinational professional services network Ernst & Young. We also have the messaging company WhatsApp. Then we have the e-commerce giant Amazon, as well as the technology and computer solutions company Dell. Finally, in our list of companies, we have the multinational technology company Google.
SQL is a very important technology that is used in the IT industry. Professionals working as application developers, web developers, data analysts, data scientists, software testers, and cybersecurity experts need to know SQL. In this video, we will cover 30 important SQL questions that are most frequently asked in the interviews. Now, these questions consist of a set of theoretical and practical questions. So we will use different commands, functions, joins, and other functionalities in Excel to solve the problems. So let's get started with the first question. So the first question is to state the difference between where and having clause in SQL. Now, where and having are very widely used in SQL to solve specific problems. Now let's look at the difference one by one. So where clause is used to filter the records from the table based on the specified condition and can be used without the group by clause. On the other hand, having clause is used to filter the records from groups based on specified conditions. Now where clauses cannot have aggregate functions, so you cannot use sum, count, average, min and maximum functions in the where clause. While in the having clause, you can operate on aggregate functions, and those aggregate functions are used to filter values from a group. Now where clause is implemented on rows or at row level. So for each row of data, you have the where condition applied. Now having clauses are implemented on columns. So for each column of data, you have the having condition applied. Now another important difference between where and having is that the where clause is executed before the execution of the group by clause and after the execution of the from clause. On the other hand, the having clause is executed after groups are created. Now we will learn more about where and having and understand the usage better when we tackle practical problems in this video. Now moving to our next question, which is how is drop different from truncate? So drop and truncate are two different commands. So drop command is used to drop the whole table, removing the table definition and its contents, while truncate deletes all the rows from the table. Now we can drop the whole table structure in one go, so the view of the table does not exist. By using the truncate command, the existence of all the rows in the table is lost, but the view in the table exists. Now integrity constraints will be removed in drop command, while the integrity constraints will not be removed when you use the truncate command. Now moving to our third question. Now this is a practical question. So we will be using a table which is present in my MySQL database. So the table name is called employees, and I want to find the lowest salary of the employees in each department. You can see here, this is how my employees table looks, and the output query would be something like this. So here, since I want to find the lowest salary of the employees, so I'm using a min function to find the lowest salary in the table, and then I'm grouping all the employees and the results by department. So let's do this on MySQL workbench. Okay, so here I am on my MySQL workbench. First, let me go ahead and create a new SQL script. So I'll click on this and that will create a new script. Okay, so here we'll write our commands. Alright, so our question was to find the lowest salary for each department. Okay, so I've given my comment to make my commands and whatever I'm doing more readable. So first, before I proceed, I need to select my database. So I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. Now this database has a lot of tables that we'll be using in this interview questions video. I'll run it. Okay, we are in our SQL intro database. Now there is a table called employees. Let me show you the table first. If I write select star from employees, okay, so here you can see this is the table I'm talking about. Now these are the rows that are present in the table. We have 20 rows, and here you can see the different columns. We have the employee ID, employee name, age, gender. We have the department, city and salary. Now this is the same table that we have also used in our other videos that are already live on YouTube. Okay, so let's solve our question to find the lowest salary for each department. Now for that I'll write select. I'll select my department column, which is DEPT, comma, and then to calculate the lowest salary or to find the lowest salary, I'm going to use the min function. So that will return the minimum salary present in the salary column. So I'll write min salary as I'm giving an alias name as, let's say, lowest underscore salary from my table name, that is employees. Then I'll write group by department. Now I'm grouping it by department because we want to find the lowest salary of the employees in each department. Now let's run and see the result. There you go. I'll just move it to the top so that you can see the results clearly. Okay, so here we have total 7 departments, you can see at the bottom, and in these 7 departments you can see in sales 70,000, let's say, dollars was the lowest salary. In marketing we had $55,000 as the lowest salary. Similarly, if I scroll down, we have other departments like tech, IT, finance and HR. So these are the lowest salary in each department. Alright, now moving to our next question. So our fourth question is, which query will help you fetch unique values from a column in a table? So this is a multiple choice question, which is another type of question that is often asked in the SQL interviews. Now we have multiple queries here and you need to choose the right query that will solve our problem. So since I want to get the unique values from a column in a table, so the right option would be to use the distinct keyword in the query. So if I write select distinct followed by the column name, let's say you want to find the distinct cities or the distinct departments in the employees table, so the query would be select distinct city or let's say department from the table name, that is employees. Hence this is the right option if you want to find any unique values from a column. Now moving to the fifth question. Now the fifth question says, it is actually a similar question here. We want to write the SQL query to fetch unique departments from the employees table. So as we saw, this is our employees table, and if you want to find the unique departments from the employees table, you can just write select distinct then followed by the column name, which is departments here, so DEPT from employees. Let's do this on our MySQL workbench. Okay, so let me just scroll down and I'll give a comment here. That is, we want to find the unique departments. So the query would be select, then I'll use the distinct keyword. If I hit tab, it will autocomplete. Then I have my column, that is department, from my table name, that is employees. If I run this, the query will give us the unique departments that are present in the table. So here we have total 7 unique departments in the table. You can see here we have sales, marketing, product, tech, IT, finance and HR. But if you see our original table, which is the employees table, so there are total 20 records, and if you see the department column, there are multiple departments to which each of these employees belong to. Okay, now moving ahead. Now the sixth question is to write an SQL query to fetch the unique values of departments and print their length. Now this question consists of two parts. First, we need to fetch the unique values of departments that we saw in our fifth question, and then we want to print the length of each of the departments. So for that, I'm using the distinct keyword to find the unique departments, and then I'm using the inbuilt length function that is present in MySQL to find the length of the department, and then I'm using an alias that is length underscore department from employees. So let's say this on our workbench. Okay, so let me give a comment. I'll say unique departments and length. Okay, so the query would be, I'll write select distinct department, and then let me just scroll down. I'll give a comma and use my inbuilt length function. See, I'm hitting tab to autocomplete, and inside the length function I'll give my column name, that is department. I'll give an alias as department underscore length from my table, that is employees. This is pretty simple. So first I'm finding the unique departments, and then using the length function I'm finding the length of each department. Let's run and see. Okay, you can see the result here. So sales, the length is 5. Marketing, the length of marketing is 9. So basically you're counting the number of characters that are present in each of the departments. So in sales there are total 5 characters, in marketing there are total 9 characters, in product there are total 7 characters, in IT we have just 2 letters, I and T, so hence the length is 2. Similarly finance is 7 and HR is 2 because we have just 2 letters, H and R. Okay, so this is another variation of using distinct along with any inbuilt function. Alright. Now moving to the seventh question. The question is, what is the use of dateDiff function in SQL? Now dateDiff returns the number of days between two date or date time or timestamp values. So dateDiff is another crucial inbuilt function that is present in MySQL. So here is how you can use the dateDiff function. So it will return the number of days between two dates or date time or timestamp values. So here I have two date values, that is 10th of April 2021 and I have 30th of March 2021. So this query will give us the total number of days that lie between these two dates. And similarly, here is another example of using the dateDiff function. So I want to calculate the total number of days that are present between today's date, so I am using the now function, and between 20th of April 2021. So let's do this demo on the workbench. Alright, first I'll give a comment saying diff function. Okay, now the way to use is I'll write select, and then you can see here once I type date, MySQL workbench is automatically suggesting some of the inbuilt functions. I'm going to use diff, and within diff I'm going to pass in two values. So I'm passing in two date values, let's say 2021 April, so I'll write 04, and let's say 10th of April. I'll give another comma, and I'll pass in my second date value, that is going to be 30th of March 2021. Alright, now another thing to note here is the date value should be present inside quotations. Now if you want, you can give an alias as well. I'll write as total days. Let's run it. There you go. It has given us the output as 10. So there are total 10 days between 31st of March to 10th of April. Now let's see another example. I'll write select date diff, and we'll pass in my now function. So the now function returns the current date, that is today's date, and I'll give another date value, let's say 2021 April 20th. Now we'll see the results. If you want, you can give an alias name so that the output is more readable here. I'll run it. Okay, so between today's date and my previous date, that was 20th of April, there are total 49 days. So today's date is actually 8th of June. So between 20th of April and 8th of June, there are total 49 days. Alright, now moving ahead. Now in the 8th question, we want to write an SQL query to display the departments that have more than 2 employees. So this is our employees table that we have been using, and here is how the command looks like. So here we are using both group by and having. Now I am grouping by department because I want to display the departments that have more than 2 employees. Now for the second filter, I am using the count function of the employee IDs and checking if the employees in each department are more than 2 or not. Let's do this. Let me move down a bit, and I'll give a comment departments with more than 2 employees. Okay, now let's write our query. So I want to select the department, and then I'm using the count function to count the employee IDs in each department, or the employees present in each department. From my table, that is employees, I'm going to group by department, and then I'll use having my count of employee ID. This should be greater than 2. So our query will return only those departments which have more than 2 employees. Let's run and see. There you go. So we have total 4 departments, that is sales, product, tech and IT, where we have more than 2 employees. You can see here sales has 4 employees, product has 3, tech has 4 and IT has 3. The rest other departments like finance, HR and others have less than 2 employees. Now if you want, you can give an alias as well. Let's say as total employees. Okay, let me run it again, and here you can see I have the column name as total employees. Okay, so moving ahead, The ninth question, we want to display the details of the employees for all the departments except marketing. Now here I have my employees table. Now if I were to display all the details of the employees apart from marketing department, I can give a condition like where department not equal to marketing. So this is the way how you write not equal to. So you use the less than and greater than symbol. Another way to do is use the exclamation mark and give equal to. So this means select all the employees where department is not equal to marketing. Now let's do this. I'll move down a bit and will give a comment as details of employees apart from marketing. So the query would be select star from employees. I'm using star because I want to display all the details. That means I want to display all the columns. Then I'm going to use my where condition where department not equal to marketing. I'll put marketing under quotes. Let's run it and see the results. There you go. So we have total 18 rows of information, and if you see the department column, we have all the departments apart from marketing. Now if you remember, our employees table had total 20 rows of information, out of which 2 are missing, which means there were 2 employees who were from marketing department and those departments were not displaying. Now another way to do is to use exclamation mark and equal to. So this also means select all the employees where department is not equal to marketing. Let's run this. You see here it gives us the same result and has returned us 18 rows of information, leaving apart the employees from the marketing department. Alright, now moving ahead. So our 10th question is to write an SQL query to print the details of the employees who have joined before April 2010 and after May 2005. So here is my employees table and this is my SQL query. So here we are using just a where condition to filter our results, and my condition is the employee should have joined after May 2005. So I have written after 31st of May 2005 and before April 2010, which is before 31st of March 2010. Let's do this. I'll give a comment here. We'll write employees joined before April 2010 and after May 2005. Now let's write our SQL query. So I'll write select star from employees where my date of join. If you see here, I have a column called date of join which has the details about the day on which the employee had joined the company. So I'm going to write where date of join is greater than 31st of May 2005. So I'll write 2005. This is one of the formats to use date values. So this is the year value, this is the month value, and this is the day value. And my date of join should be less than 31st of March 2010. So I'll write 2010 March 31st. I hope you were able to understand this. Date of join greater than 31st of May 2005 means after May 2005, and date of join less than 31st of March 2010, this means employees joined before 2010 April. Let's run it. Okay, so we have total 3 employees in our table. You can see the date of join, and all of them have joined after May 2005 and before April 2010. Okay. Now moving ahead to the 11th question. So here we want to find the employee with the third highest salary from the table. So I have my employees table here, and my command would look something like this. So here we are going to explore how to write subqueries in SQL. So I'm using a subquery here where I'm trying to find the employees who have the top 3 salaries, or the top 3 employees who have the highest salaries, and from that I'm going to filter out my third highest salary employee. So let's do it on our workbench. Okay, so I'll come down and let me give a comment as third highest salary. Okay, so let me first write down my SQL query and then I'll explain. So I'll write select star from. After that I'll start a bracket and write my inner query. So I'll write select star from employees order by salary descending. Then I'll use my limit keyword and I'll write limit 3 as I'll give an alias name, let's say T, and then I'm again going to use my order by salary limit 1. Okay, now let me explain you the flow. So first let me run the inner query. I'll select my inner query and I'll run it. So the inner query returns my top 3 employees who have the highest salary, and this is ordered in descending order since I used salary descending. Now let me just use this. Okay, now you can see it clearly. So these are my top 3 employees who have the highest salary. So Joseph has the maximum salary, followed by Angela, and then we have Jack. Now from this I want to return only the record for Jack, because Jack is the employee who earns the third highest salary. So for that I am going to use the result returned by my subquery or the inner query, and on top of this I'm going to order the salary and say limit equal to 1. So I'm again ordering this salary in ascending order. So what will happen? Jack will appear at the top, Angela will be at the second place, and Joseph will come to the third place. And from there I'm using limit 1 so that I can only get the record for Jack. Now if I run the entire query, you see the result. I have my employee name as Jack who earns the third highest salary. Okay. Now moving ahead to the 12th question. The question is to print all the alternate records in a table. So here is my employees table, and from this table I am going to print all the alternate records. For example, I am going to print my employee ID 101, then I am going to skip 102 and print 103, followed by 105, 107, 109. So all the employee IDs that have an odd value. And you can look at this example in another way of displaying the employees which have an employee ID of even numbers. So 102, 104, 106 and so on. Now the way to do is, either you can use a simple select clause and say employee ID percentage or modulus 2 equal to 0, which means I want to filter only those employees which have an even employee ID. Else what you can do is you can use a CTE, as you can see here. So CTE, or the common table expression, is a temporary named result set that you can reference within a select, insert, update or delete statement. Now it is used to simplify complex joins and subqueries and to provide a means to query hierarchical data. Now let's write this query on our workbench and see how it works. But before that, let me explain you. I am using a few new functions such as row number. This will create a row number for each of the rows or the records present in my table, and then from this CTE I am going to use my filter clause or the where clause, where rn, which is row number, %2 equal to 1. So this will return only the odd records from the table. Let's see how to do it. Okay, so I'll give a comment, print alternate records. Okay, now I'll start with my simple query, which is select star from employees, where let's say I want to find only the even employee IDs or the employees who have an even employee ID. So I can use employee ID %2 equal to 0. So it has to be a perfect division and the result should be 0. Only then I can get only the even employees. If I run this, okay, there was an error here. It should be employees. I'll run it again. You can see here I have printed the alternate records in a table. So we have skipped 101 because it is not divisible by 2. I've started with 102, followed by 104, 106, 108, and then finally we have 120 or 120. Now if you want to print only the odd records in the table, you can use employee ID %2 equal to 1. So you can see here I have 101, 103, 105, 107 up to 119. Now the best way to do this is to use a common table expression or CTE. So I'll start with my command, that is with CTE, as I'll start with my bracket. I'll write select star comma, then I'm going to use my row number function. So I'll write row number, then I'll write over, then I'll use order by employee ID. So this row number for each of the rows is going to be created over my employee ID column, and that is sorted in ascending order. I'll give an alias as rn, which stands for row number, from my table, that is employees. I'll scroll down and then I'm going to close my bracket. I'll write select, let me remove the space here. Okay, I'll write select star from CTE, where my row number %2 equal to 1. Now let's see this from the top. So I have my common table expression where I am going to create a row number column named as rn, and this row number column is based on my employee ID column, which is sorted in ascending order, and from that I'm going to filter only those row number values that are not divisible by 2, or I'm going to print only the odd records from the table. So let's run it and see the results. There you go. So here if you mark, I have my row number column created and I am filtering only the odd records in the table. So it starts with 1, 3, 5, 7 and goes up to 19. And similarly here you can see the employee IDs, the name, the age, gender and other information. Now if you were to print the even records in the table, the alternate even records, you can use rn %2 equal to 0. Let's see the difference. I'll run this. There you go. So I have my even row number starting from 2, which which goes up to 20. Okay, so this is how you can print alternate records in a table. Now moving to the next question. Now in the 13th question, we want to write an SQL query to fetch all the duplicate rows in a table. Now this is another crucial interview question that is often asked in most of the interviews. Now I have a table which is named as duplicate table, and here you can see I have some employee ID, name and age, and a few records are duplicated. For example, 101 Sam 40, the first record is duplicated, and you can see here it has the same values. Now if you mark 103 Mary and 28 is not duplicated because here the age is different, so this is a different person than compared to the third name that we have. So this is how you can find the duplicate rows in a table. So I'm going to select my employee ID, name and age, and then count all the employee IDs, the names and age, and compare them with whether they are greater than 1 or not. So if they are greater than 1, then I'll say that particular record is duplicated or is present more than one time in the table. Let's do this implementation on our workbench. Okay, so I'll come down and let me give my comment as duplicate records. Okay, so let me first show you the records that are present in my table. So I'll write select star from dup underscore employees. I'll run it. Okay, you can see here I have my table that we saw in the slides. So employee ID 101 with name Sam and age 40 is duplicated. So we want to find this duplicate record. The way to do is I'll write select e underscore id, which is employee ID, comma name, comma age, comma I'm going to count all of them. So I'll write count star as duplicate count. This is my alias name from my table, that is dup underscore employees. I'll say group by employee ID, name and age, and then I'm going to use my having clause saying having count of employee ID is greater than 1 and count of name should also be greater than 1 and my count of age should also be greater than 1. Let's run it and see the results. Okay, there is some error here. The name of the table should be employees. Okay, let's run again. We have our correct result, that is employee ID 101 with name Sam and age 40 is duplicated, so the value is 2. Great. Now moving ahead. Now the 14th question is a bit tricky, wherein we want to display the employees with exactly 2 A's in their name. So you see here I have my employee names and there are certain employees who have just 2 A's in their names. So I want to find those employees only. Now the way to do is, it is a bit tricky to understand. I'm going to break it down and make you understand on my MySQL workbench. So here you can just have a glance. I write select star from employees where I am finding the length of my employee name and then subtracting my length wherein I have replaced my employee name that has A with a blank, and if this subtraction is equal to 2, then that particular employee has 2 A's in their names. So let me show this first. Let me first give my comment as employees with 2 E's. Okay. So first I'm going to write a select statement. Okay, before that I'll show you the records present in my table. Okay, if you see here, Shane is one of the employees that has just 1 A in its name. Then we have Mary 1 A, Dwayne has 1 A, but if you see Sarah has 2 A in the name, so we want to extract Sarah. Then Jack has 1 A. Again, if you see Angela has 2 A. It doesn't matter if it is uppercase A or lowercase a, we just need to find if the employees have 2 A's in their name. And similarly, if I scroll down, let me check if we have any other employee with 2 A's in their name. Marcus has 1, David has 1, Sophia has 1. We also have Amelia that has 2 A's in its name or in her name. And we also have Maya. Okay, now let me go ahead and write a SQL query, and then I'll explain you what I'm trying to do. I'll write select. I'm using the length function, and in the length function I'm going to replace, then I'll use another function called upper on top of employee name. I'll write A and then replace it with a blank. So I'm using quotations to represent blank from employees. Okay, let's run this and see the results. You see here it has given us the length of the employee strings after replacing all the A's with a blank. So here I'm essentially converting my employee names to uppercase, and I'm changing wherever there is an A, I'm replacing that A with a blank, and then I'm finding the length. So this trick I'm going to use in my final query. So I'll write select star from employees, where what I'm going to do is I'll bring this to the next line. I'll write length of employee name minus, then I'm going to use my above condition. I'll copy this, I'll paste it here, and this value should be 2. So what I'm doing is I am first finding out the length of my employee name. From that I'm subtracting the length after replacing the A's present in the employee name with a blank, and this value should be equal to 2. The reason being we are only trying to find the employees who have 2 A's in their name. Let's run and see the results. Okay, if you see here we have Sarah, Angela, Amelia and Maya who have 2 A's in their name. So we have Sarah that has 2A, Angela has 2A, Amelia has 2 A's, and then Maya also has 2A. Okay, now moving ahead. Now the 15th question is, given a string, how will you extract 4 characters starting from the second position? So I have my string here which says Michael Ballack. Now Michael Ballack, you must be aware, is a popular footballer. He is from Germany and also was the captain of Germany. So from the string Michael Ballack, I am going to extract 4 characters starting from the second position. You can use 2 inbuilt MySQL functions to do this. The first is called substr, wherein we pass in the string, then we give the position from where we want to extract the characters. So here I'm going to extract from the second position, so hence 2, and then the number of characters that you want to extract, which is 4. The other way is to use the substring function, which is again similar to the substr function. In the substring function also, I am first passing in my input string and then giving my starting position, which is 2, and then I want to extract 4 characters from it. Let's do it. I'll give a comment, extract strings. So here I'm going to write select. First I'm going to use substr, which is my inbuilt function. I'm going to pass in my input string, which says Michael Ballack, and then I'll give my starting position, which is 2, and then the number of characters, that is 4. Let's run it and see the results. You can see here it has given us ICHA. So if you see, M is at the first position. From the second position onwards, I needed 4 characters, so M, C, H and A. These are the 4 characters starting from the second position. Similarly, let me just copy this, and instead of substr, I'm going to use the substring function. I'll write just ing, that becomes substring. Let's select and run it, and this also returns the same result. Suppose you wanted to extract from the 4th position, you wanted to extract, let's say, 3 characters. Let's see the results. It gives us H, A and E. If you see here, M is the first position, I is at the second position, C is at the third position, H starts from the 4th position. So H, A and E are the next 3 characters starting from the 4th position. So hence this is the result. Alright, now moving ahead. Now my 16th question is on how does self-join work. So self-join joins a table to itself. So the table must contain a column X that acts as the primary key, and a different column, let's say Y, that stores values that can be matched up with the values in column X. Now this might not be really easy to understand. You'll get to know once we do this demo. So I have a table which is called employee manager. So this is my table. Now let me tell you how to interpret this table. We have 5 different employees starting from employee ID 1 to employee ID 5. Gary, Gibbs, Smith, Latham and Jimmy are the different employees we have. You have their salaries, and now you have the employees reporting to which manager. Now if you see here, Gary's manager ID is 3. So if you see our table, at 3 we have Smith. So Gary is reporting to 3, or in other words, Smith has a employee under him who is Gary. Similarly, Gibbs is reporting to manager ID 1 or employee ID 1, which is Gary. So Gibbs manager is Gary. Similarly, if you see for Smith, Smith is reporting to the person with manager ID 4 or employee ID 4. We have Latham. So Latham has 1 employee under him who is Smith. Now Latham in our table has no managers. Then we have Jimmy who's reporting to the employee ID 3 who is Smith. Okay. Now I want to use this table and return the name of the manager for each employee. To do that, I am going to use my self join. So here I am using a self join to join both the tables. Here both the tables mean I am using the same table twice. So I have written select e.employee ID, e.employee name, then we have e.manager ID. Then I am using another alias for managers, so m.employee name as manager underscore name from employee underscore manager as e. This join means self join employee underscore manager as m on e.manager ID equal to e.employee ID. So this is my common column, that is employee ID and manager ID. Let's do it. Alright, I'll give a comment here saying self join, and I'll start with my self join. I'll write select. Let me first display my table. I'll write select star from, and my table name is emp underscore manager. I'll run it. You can see the table here. This is the same table that we saw in the slides. Now I'll write my join query. I'll write select e dot employee ID, comma, e dot employee name, comma, e dot manager ID, comma, then I'm using another alias as m for finding the manager name, so m dot employee name as manager name. There shouldn't be any space in the alias name. Then I'll write from emp underscore manager as e, join emp underscore manager as m on e dot manager underscore id equal to m dot emp underscore id. Let me run this and we'll see the results. There you go. So Gary reports to the manager ID 3. So from the table, 3 is for Smith. So Gary's manager is Smith, Gibbs' manager is Gary, Smith's manager is Latham, and Jimmy's manager is Smith. Okay, so this is how you can use self join. Now moving ahead with our next question. So the 17th question is on which of the following is called a virtual table in SQL. So again we have a multiple choice question. So the answer is view. You can see here. So view is a virtual table that has rows and columns as they are in a real table in the database. Now we can create a view by selecting fields from one or more tables present in the database. Next, moving to the 18th question. So here we want to write an SQL query to fetch the list of employees with the same salary. Again, I am going to use a self join here, wherein I'll join the same employees table, and this is how my query would look like. So I am selecting distinct employee ID, so e dot employee ID, e dot employee name, e dot salary from employees. Then I'm joining employees as e on employees e1, where e dot salary equal to e1 dot salary, because I want to fetch the list of employees with the same salary, and I'm ensuring that the employee IDs from both the tables are different. Let's do it. I'll give a comment here and write employees with same salary, and I'll start with my query. I'll write select distinct e dot employee ID, comma, I'll write e dot employee name, comma, e dot salary from employees as e, then employees as e1, where e dot salary equal to e1 dot salary and e dot employee ID is not equal to e1 dot employee ID. I'll give a semicolon and let's print the results. You see here we have Amelia, Bella, Shane and Sarah who have the same salary. So Amelia and Shane have the same salary of $55,000. Bella and Sarah have the same salary of $72,000. Okay. Now moving to the 19th question. So the question is to write an SQL query to print one row twice in results from a table. So I have a table here called employees and I want to print one row twice in the results. So to solve such kind of problems, you need to use the union all operator in SQL. So union all combines the result sets of two or more select statements. It does not remove duplicate rows. Between the various select statements, all the rows are returned. So let's say I want to print the employee name and department for those employees who are from the HR department. Now to do this, we can use the union all operator. You can see it here. So I'm selecting my employee name, the department from my table employees as E. Then I'm giving my where clause where E.department equal to HR. And then I'm using the union all operator. Then I'm again selecting my employee name, department from employees with another alias as E1 where E1.department equal to HR. So let's do this. Okay, so I'll give my comment as print row twice. Okay, now I'll start with my query. I'll write select my employee name, comma, the department from my table that is employees as E. Then I'll use where E dot department equal to HR. Then I'm going to use the union all operator. So the union all will combine the result set of two or more select statements. Then I'm going to write select emp underscore name, comma, my department from employees as E1 where E1 dot department equal to HR. I'll give a semicolon. Now let's run it. There you go. You can see here Marcus and Sophia are from the HR department and we have printed them twice in our results. Coming to the next question. The question is, using the num table, write a query to add 10 when number is 0, 20 when number is 1, else print the number itself. So you can see here I have my table called num and it has just one column which is num id or number id. We have some numbers here and from these numbers I want to add 10 if the number is 0, 20 if the number is 1, else I would print the number itself. So to answer this question we'll use the case statement in SQL. So the case statement is SQL's way of handling if-then logic. The case statement is followed by at least one pair of when and then statements. So here you can see I have my case statement. I'm writing when case, my column name n underscore id equal to 0, then add plus 10. If it is 1, then add plus 20, else we'll just return the number id. Now let's do this. Okay, I'll give a comment saying using case statements. Okay, first of all let me display the values present in my NUM table. You can see here this is my table and there are total 12 rows of numbers. Now let's start with our query. I'll write select n underscore id, comma, then I'm going to write my case statement. So I'll use the keyword as case when n underscore id equal to 0. I'll use then n underscore id plus 10. I'll write when n underscore id equal to 1, then n underscore id plus 20, else I'll just print NID. Now I'll end my case statement. I'll write end as an alias name, let's say num underscore add, from my table that is num. Let's run and see the results. Okay, you can see here my first number was 0. So since it was 0, we have added num id or nid plus 10. So the result is 10. Now wherever the num id is 1, for example here we have added 20, so the result or the output becomes 21. Similarly here the value was 0, so we have added 10, the output is 10. And you see here again, here we had another 1, so we added 1 to 20, so the result becomes 21. And for the rest of the numbers, for example 3, we had 2, the values are the same. Okay, now moving ahead. So we have a table called num1, and using this table we want to write a query to find the sum of all positive values and the negative values. So let's see the table first. So this is my table, which is num1. You can see here we have a list of integers, and there are positive as well as negative integers. So for positive values and the negative values, we want to find the sum separately. So again, for this we are using the case statement. You can see here I have used two case statements. I'm writing select, and then I'm using the case to find if the number is greater than 0, which means it's a positive number. So I'm finding out the sum, and then I'm checking case when the integer is less than 0, so it's a negative number, and I'm finding the sum for the negative numbers as well. Let's do this. Okay, so I'll give my comment as add positive and negative numbers. Okay, so let's start with our select query. I'll write select. I'll use the sum function, and inside the sum function I'll use my case statement. So I'll write case when num underscore integer. Okay, before that let me just print the values present in my table. So I'll write select star from my table name, that is num1. Okay, so you can see here these are the values or the list of integers that we have. There are some positive as well as negative integers. Okay, let's continue with our query. So here I'm going to write case when num underscore integer or int, which is my column name, if it is greater than 0, then I'll return num underscore int. Else I'll say 0 and end my case statement. I'll give an alias as sum of, let's say, positive numbers. I'll give a comma. Then I'll use another sum function, and inside the sum function we'll use the case statement to find the sum of negative numbers or integers. So I'll write num underscore int. If it is less than 0, then num underscore int, else 0, and I'll end. Okay, and I'll give another alias name as, let's say, sum underscore neg, which stands for negative. POS is for positive integers, and then I'll write from my table, that is num1. Let's run it. Okay, there you go. We have our results. So we have two columns, sum of positive integers and sum of negative integers. You can see the results, 19 and minus 14 respectively. Okay, now moving ahead. Now in question number 22, we want to list the difference between primary key and foreign key. So as you can see here, primary key is something that can uniquely identify a record in a table. So if you consider a school database, a primary key would ideally be the roll number or the registration number of the student, because that is unique to all the students in a school. Now, foreign key is the field in the table that is primary key to another table. So suppose you have another table called courses to which the students have enrolled to. Now, if you have a roll number or a registration number column in the course table, that becomes the foreign key. Now, the other difference is primary key don't accept or cannot accept null values, while foreign key can accept null values. Now, you can have only one primary key in a table, but you can have more than one foreign key in a table. Now, coming to the 23rd question, what is the difference between primary key and union? So you can have only one primary key in a table, as we discussed in the previous question, but you can have more than one unique key in a table. A primary key column cannot have null values, but union can accept null values. Now, if you assign a column as a primary key, you create a clustered index, and similarly, if you assign a column with union, you create non-clustered index. Okay. Now coming to the 24th question, what is a check constraint in SQL? So check constraints are used while creating tables. Check constraint helps to limit or restrict the values that can be inserted into a column. For example, we have a table here, let's say dummy 1, and you want to ensure that every time you insert the age of people or persons in the table, you want to make sure that age should be always greater than 0. Reason being, a person cannot have, or an animal cannot have, or a tree cannot have a negative age. Similarly, you can set a constant for the salary column in a table to ensure that it is always greater than 0, because you cannot earn a negative salary, or it cannot be less than 0. Now we are going to create a dummy table on my MySQL workbench and see how check constraints can be applied. Okay, so let's give our comment as check constraints. Alright, so I'm going to create a table called dummy, let's say underscore SQL. Now this table will have a few columns. First we have, let's say, EID, which stands for employee ID. The data type is integer, and I'm going to assign employee ID as my primary key. So I'll write primary key here. Okay, I'll give a comma. Next we'll have a city column. City column is of type var_char or varying character. I'll give the size as 30, and here I'm going to apply my check constraint to this city column. I'm going to check the city should take only values as Mumbai. Let's say I'll have my final column, that is age. Age is of type integer, and here I'm going to check my age should always be greater than 0. So I'll write check age greater than 0. Okay, so our dummy SQL table has one primary key constraint, and we have applied two check constraints on city and age column. Let's run this. Okay, so we have created our table successfully. You can see it here. Now let's insert a few records and we can see the difference. I'll write insert into dummy underscore SQL. I'll write values. I'll have my employee ID as 101. I'm giving my city as Mumbai, which is what we want. and let's say I'll give my age as 10. Now this should perfectly work because my city is Mumbai and my age is greater than 0. So I should be able to insert this record successfully. You can see here I have inserted this record to the table. I'll write select star from dummy SQL so that you can check. Let's run it. There is some mistake. I should write from. Okay. Let's run it. You can see it here. We have one record or one row returned. Now let's say we'll insert another record, and this time I'm going to give my employee ID as 102 because it has to be unique. And this time instead of Mumbai I'm going to give my city as, let's say, Delhi. So I'm not following my check constraint where I am supposed to give only Mumbai. I'm purposely giving Delhi here to see the difference. If I run this, let's say we'll have age is 40, which is greater than 0. Let's run it. You see here we get an error saying check constraint dummy underscore SQL underscore check is violated. Similarly, let's say I'll change this to Mumbai again, and instead of 40, let's say I'll give us minus 30. So your age can never be in negative numbers. If I run this, I get the same error. My check constraint has been violated because age should be greater than 0. Okay, so this is how you can use check constraints in SQL. Now coming to the 25th question. So given two tables A and B, you want to write a query to fetch values in table B that are not present in table A. Now to answer this question, you can use the left join. So what left join does is it returns all the rows from the left table and only matching rows from the right table. And I've used my condition as a.id, which is in the right table, should be null. Let's write this query on the workbench. Okay, so I'll give my comment using left join. First of all, let me display my tables. I'll write select star from A. If I run this, I have the IDs. There are total 5 IDs in table A. Similarly, I'll copy this and we'll see the values that are present in table B. So again, I have 5 values. There are a few non-matching values as well. So I want to return those non-matching values that are not present in table A. So for that, I'll write select ID from table B. I'll use left join A using my ID column. This is another way to give the condition, or you can use the on operator. Then I'll give where a.id is null. Let's run and see the results. There you go. So 150, 275 are not present in table A but are present in table B. Okay. Now moving ahead. So now we'll look at the last set of 5 questions. So these questions are based on the popular Northwind sample database provided by Microsoft. Now there are several tables in this database. So we have an order table, customers, employee, products, a region table and others. We'll use our Microsoft SQL Server to solve the 5 questions. So my next question, which is based on Microsoft SQL Server, the question is, using the Northwind database, find the customers who don't have any orders. Okay, So I am on my Microsoft SQL Server Management Studio. So this is how the interface looks like, and here you can see I have a list of databases. Now to solve the last 5 questions, I'm going to use the Northwind database. If I expand this, I'll click on the plus sign. You can see there are a lot of tables that are already present in the database. You can see here we have customers, employees, employee territories, order details, orders, products, region, shippers, suppliers, territories, and more. Okay, let me just collapse this. Alright, so to write my queries, I'm going to create a new query file, and here you see I am currently on my master database. I'm going to change this to Northwind database so that we can utilize all the tables that are present. So my 26th question was to find the customers who don't have any orders. So for that, I'm going to use two tables, customers and orders. So let me first give a comment saying customers with no orders, and now let's go ahead and display the columns that we have and see the records present in the tables customers and orders. So first I'm checking all the columns and the rows present in the customers table. I'll execute using this button, or you can hit F5 as well. Okay, you can see here there are total 91 customers. These are all unique customers. You have total 91 unique customer IDs. You see here the company name of the customer. You have the contact name, the contact title, address, city to which the customers belong to, then the region, postal code, country, phone, fax number. Okay, now let me just copy this query, and now we'll check for the orders table. I'll write select star from orders, and let's execute it or run it. Okay, so there are total 830 rows of information. So there were total 830 orders or order IDs. We have the customer ID. Now this customer ID is actually the foreign key for the orders table, but for the customers table, customer ID is the primary key, and in the orders table, order ID is the primary key. We also have the employee ID. Again, this employee ID is the foreign key for this orders table. We have the order date, we have the required date, ship date, ship via, which means by which medium the order was shipped. We have the freight charges, ship name and ship address as well. Then you have the city from which the item was shipped, the region, postal code and the country. Okay, now let me use the distinct keyword. I'll write select distinct. I want to find the distinct customer IDs from my customers table. Let's run and see how many unique customer IDs we have. So there are total 91 customer IDs or customers. Now let's check for the orders table. Let's run it and see the difference now. If you see here, there are total 89 customer IDs in the orders table, which means there are 2 customers missing from the orders table, and that implies those 2 customers don't have any orders. So to get the result, I will use 2 different queries to derive at the same output. So I'm going to select my customer ID from my table, that is customers. I'm going to use where my customer ID, and then I'm going to use the not in operator. I'm going to use a subquery select customer ID from my orders table. Close the bracket and I'll give a semicolon. Now what this query essentially does is, it is first going to find all the customer IDs that are present in my orders table, and in the outer query we are only going to return the customers that are present in both the tables, and we are going to exclude those customers which are not present in the orders table. So let's run and see the results. We should get 2 customer IDs. There you go. So these are the 2 customer IDs which are present in the customers table and are not present in the orders table, meaning that they don't have any orders in their name. Now there is another way to do it, that is to use the not exists operator, wherein you can write another subquery to get the same result. We'll leave that to you. You can try this out using the not exists operator as well. Coming to the 27th question. Using the orders table in the Northwind database, we want to find all the month-end orders. So such problems you will face while dealing with sales data. So very often sales executives would try hard to meet their month-end targets. We want to display all the orders made on the last day of the month. So let's solve this question on our Microsoft SQL server. Okay, so let me first give my comment for the 27th question. So the question is to find all the month-end orders. So I'll just write month-end orders. Okay, now to get the month-end orders, we are going to use a built-in EO month function which stands for end of month. So let's start with the query. I'll write select. We are going to select the employee ID, comma, I also want the order ID, and we want the order date from my table, that is orders. I'll then give my where clause. I'll write where my order date equal to, and I'll use my inbuilt function, that is end of month. I have hit tab to autocomplete, and inside this function I'll pass in my order date column. Then I'm going to use the order by clause. I'm going to order it by employee ID and the order ID. I'll just move down and hit tab. Okay, let's run the query. There you go. We have got 26 rows of information. You see on the left side we have the employee IDs, the order IDs, and then we have the order date column. Now if you mark the values present in the order date column, these are all the end of month date values. You see this is 28th of Feb, then we have 31st of July, we have 30th of June, so on and so forth. So these are the list of all the orders that were placed on the last day of the month. Now coming to the 28th question, we want to find the top 5 countries with the highest freight charges in the year 1997. So freight charge is the amount paid to a carrier company for the transportation of goods from origin to another location. The freight charge is calculated based on the mode of transportation and the distance between the pickup place or the pickup location and the destination. So let's try this out on the Microsoft Server Management Studio. Okay, so let me go ahead and give my comment. So since we want to find the top 5 countries with the highest freight charges, I'll just give my comment as highest freight charges. Okay, now to solve this question, I'll just change this to GHT. Okay, we are going to use our orders table. So the way to do is I'll write select. I'm going to use the top 5. So top is another keyword or an operator. So I'm going to find out the ship country, and then I'll calculate the average freight prices. So I'm going to use the average inbuilt function on top of my column, that is freight. I'll give an alias as, let's say, average freight. There should be no space. I'll give a underscore. I'll write from my table, that is orders. I'll use my where clause where, and then I'm going to find the year from my order date column, and this year should be 1997. I'm going to group it by my ship country, and I'll use order by my alias name, that was average freight, and in descending order I'm going to sort it. Let's see the top 5 shipping countries who have the highest freight charges. These are the results. You have Austria, Switzerland, Sweden, Canada and Ireland, and here you can see the average freight prices sorted in descending order. Okay, now moving ahead to the 29th question. So here we want to display the total number of products in each category. So we have two different tables, products and categories. So both these tables we are going to use to find a solution to this problem, that is to display the total number of products in each category. So first let me give my comment to display the total number of products in each category. I'll just write print total products. Okay, so to solve this problem we are going to use our two tables. So let me first display the rows and columns from both the tables. The first table is products. Okay, it is products. Let's run this and see the columns that we have in this table. Okay, so you have the product ID, which is the primary key. You have the product name. So there are total 77 different products. Okay, and then you have the supplier ID, you have the category ID. So these two columns are the foreign key columns. You have the quantity per unit, unit price, units in stock, units in order, and if you want to reorder some product to fill in the stocks, so you have information for that as well, and if the product has been discontinued or not. I'll copy this and let's see what rows and columns we have in my categories table. Okay, let me execute this. Okay, so we have total 8 categories of products. You can see beverages, we have dairy products, meat or poultry, you have produce, seafood. These are the description. Okay, now to find the total number of products in each category, I'll write my query as select. I'll write category name, comma, count star. I'll give this an alias name as total products. Give an underscore and write products from my first table, that is products. Give an alias as P. I'm going to use an inner join with my categories table, and I'll give my alias as C on my common key column, that is P dot category ID is equal to C dot category ID. Then I'm going to group my results based on the category names. So I'll write category name and we'll use the order by clause. I'll write order by count star as descending. So let's see the total number of products that we have in each category. So this shouldn't be as descending, should be just count star descending. Okay, I'll select and run it. There you go. So here on the left hand side you have the different category names, and on the right you have the total number of products that belong to each of the categories. Alright. Now moving on to the final question. So the last question is to use the Northwind database, and using this database we want to find the list of late orders for all the employees. So this is a real world problem that often occurs. So the shipment of your orders might get delayed due to logistic issues, or if the products are not available on time. There can be various other reasons as well. So here we want to find those orders for the employees where the required date is less than the shipment date. So we are going to use two different tables, that is orders and employees. Okay, now let me give my comment for the final query that we are going to write in this interview questions tutorial. So using the orders table, I want to find the list of orders for all the employees. So I'll just give list of late orders, not just orders, for employees. I write EMPS, which stands for employees. So here I'm going to use two tables, orders and employees. Orders table we have already seen. Let's see the rows and columns that are present in the employees table. I'll write select star from employees and let me run it. Okay, so there are total 9 employees we have. So we have the employee ID, this is the primary key column which goes from 1 to 9. We have the last name of the employee, the first name of the employee, we have the title, then we have the title of courtesy, whether doctor, Mr., Mrs. We have the birthday of the employee, the hire date or the date of join. You have the address, city, region, postal code and other information. Alright, so let's see how you can join the orders table and the employees table to get the list of late orders. And we must remember that late orders are those where the required date is less than equal to the shipped date. So I'll start with select e dot, I'll write employee ID, comma, I want the first name, comma, I'm going to count star as late orders from my table orders as O. Then I'll use my inner join. I'll write employees as E. It doesn't matter actually if you use small e or capital E. Then I'm going to use my on condition on e dot on e dot employee ID equal to O dot employee ID. So this is my common key column that is present in both the tables. Then I'll use my where clause where. Now you should be careful and you should give the right clause. So my required date should be less than or equal to my shipped date. So this is my condition, and then I'm going to group by e dot employee ID, comma, e dot first name, and then I'll use my order by clause, order by my alias name that was late orders, and I'll arrange it in descending order. So let's run this and see our result. Okay, so you have the employee IDs on the left, then you have the first name of the employee IDs, and then you have the late orders for each of these employees. So if you see here, employee ID 4 has the highest number of late orders, followed by employee ID 3 and 8 as well as 9 who have 5 late orders. Then we have the employee ID 2 which has 4 late orders, even employee ID 7 has 4 late orders. Employee ID 5, that is Steven, has only 1 late orders. So we are done with our demo section and we have covered all our 30 questions, out of which 25 questions were based and used on MySQL server. And to address the last 5 questions, we used our Northwind database that had a lot of tables. You can see it here, and using those tables we solved some interesting questions.
So are you ready to get started with this amazing career? Check out postgraduate program in full stack web development by Simplilearn. So hurry up and enroll now. Find the complete course details from the link in the description box.
Data is getting bigger day by day, and it has a significant role in decision making for companies. Now, in order to handle these huge amounts of data, there is a need for database and database management systems. Now, in order to communicate with these databases, you need a tool. This is where SQL comes into picture. Would you like to ace the most frequently asked SQL interview questions during your campus placements to land in your dream company? Well, you're at the right place. And on that note, hello everyone, welcome to Simplilearn's YouTube channel. I hope you guys are doing good and staying safe. In this tutorial, we will be taking you through some most commonly asked SQL interview questions in 2022 and for 2023. We'll look at some of the key things that you need to keep in mind while answering these interview questions. The general questions will revolve around key concepts like commands, constraints, joins, functions, transactions, and other database related questions. You may also get some scenario based questions wherein the interviewer might ask you to write queries other than the theoretical questions wherein the interviewer wants to test your knowledge in depth. So we'll be going through all these technicalities and see how to answer these questions in your next interview. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel Simplilearn to stay updated with all the latest tech content, and hit that bell icon to never miss an update from us. So without any further ado, let's get started. So the first question is, what is SQL and why it is used? SQL, or Structured Query Language, refers to a standard programming language utilized to extract, organize, manage, and manipulate data stored in relational databases. SQL is thereby referred to as a database language that can execute activities on databases that consist of tables made up of rows and columns. SQL commands are used to process, analyze, and manipulate the data that is stored in databases. SQL plays a crucial role in retrieving relevant data from databases by performing various operations like insertion, updation, modification, and deletion. SQL can manage several data transactions simultaneously where large volumes of data are written concurrently. So that is SQL and why it is used. Moving ahead, let us now discuss our next question, which is why we need a database. As the technology kept on advancing, the file system had become difficult to handle when the number of files increased and the volume of data also grew. This is where database comes into picture. The system was no longer able to store and retrieve data efficiently, and this created some limitations and drawbacks, and that is when we needed a new medium through databases. Now the problem with traditional file systems is we have data redundancy and inconsistency. Redundancy means when the same data is getting duplicated and repeated in different locations. This leads to excess and unwanted storage, which eventually results in inconsistency where the data in different files does not match with each other. Data isolation. Data is isolated because it is scattered in various files in different locations, and the files may be in different formats as well. At any point, writing new application programs to retrieve the appropriate data becomes difficult as the files are separated from each other in different locations. Limited data access. File storage systems usually do not have access for multiple users. This means multiple users at different places cannot access the data simultaneously. It becomes difficult to access important data if multiple users are searching at the same time. Security and integrity issues. Data is of paramount importance to anyone, and its privacy and its security is one of the most important things we need to consider. Data stored in files can be easily accessed and tampered, so it is important to prevent access to unauthorized users to hold the integrity of the stored data. So in order to eliminate all these drawbacks, we use a database which is further controlled by a database management system. Alright, moving ahead, the next question is, how does an SQL database works? Now, database store related information across multiple tables and allows you to query information using SQL commands. But the process, it is a bit of a hectic one, and in order to understand this in a simple way, I have put a flow diagram here where you can understand how the flow between the user and the SQL engine through the database server is happening. Now, a typical SQL database engine includes a storage engine, which is a database server, and the query processor within the SQL engine. Now, to retrieve the data, the query processor in the SQL engine accepts and executes SQL commands for the database server, which forwards to an application server. Now, this application server within the database processes the SQL request and sets it to a web server, where the user can access the information via SQL tables. If the required data is found in the tables that is present in the database server, it sends the information back to the user. In this way, one can find the data that is needed from the database by writing simple SQL queries. So this is how a traditional SQL database works. I hope you guys have understood. Let us now move ahead and discuss the next question, which is, what are the main usages of SQL? Or you might be asked, what are the features of SQL? Or you might be asked why we use SQL. Now, SQL is responsible for accessing and manipulating the data present in databases by writing simple SQL queries. Now, the main function or the main usages of SQL is it is used to execute query against a database. Now, by writing a simple query, you can perform complex operations to retrieve data from the database. You can also perform various operations like insert, update, and delete records. For example, if you have created a new table, you can insert records in that. Now, due to some reasons, if there is a modification or a change in the record, you can use the update statement to modify them. And finally, if you no longer want to process that data or show the data in that table, you can use the delete command to delete that data present in that table. And again, as discussed earlier, it is used to perform complex operations on the database like functions, by joining two or more tables, and etc. The next question is, what do you understand by tables and fields in a database? A table is a set of data that is organized in a model in the columns and rows format. Tables are considered as the fundamental level to store data in a relational database management system. It contains a header row at the top of the table, which gives the list of column names. Now, the tables contain rows and columns where the rows are known as records in general and the columns are known as fields. Now, a column is a set of data values of a particular type like numbers or alphabets. For example, if you consider the employee table here, which has employee ID, employee name, job, department number, salary in the column names, which is basically considered as the different fields. And we also have different records present in this table. Like if you consider the employee details of Rohan, whose employee ID is 1011, who's working as a data analyst. So fields are basically columns in a table with specific information about the data, and a record is basically an individual entry that exists in a table. Alright, the next question is, explain different types of commands in SQL. Now mainly there are 4 types of commands in SQL. The first one is Data Definition Language or DDL. Data Definition Language helps you to define the database structure or schema. Data Manipulation Language or DML. DML allows you to modify the database instance by inserting, modifying, and deleting its data. Next, we have Data Control Language or DCL. DCL gives access to the data stored in the database by granting and revoking permissions to the user. And finally, we have Transaction Control Language or TCL. TCL commands deal with the transactions within the database. So these were some of the important and mainly used SQL commands. Now moving ahead, you might be asked to explain any one of the SQL commands in detail. So I've taken another question here which states that what are the statements used under DML commands. So you need to prepare accordingly and thoroughly so that interviewer want to know whether you have the in-depth knowledge of the SQL commands or not. Now, typically under DML commands, we have 4 statements. The first one is select. This command is used to fetch data from a database table. Next, we have insert. Insert is used to insert data into a table of a database. Now, if you have created a database and if you want to insert some record into it, you can use the insert statement. Next, we have update. Update command allows modifying a data in the table. Now, as discussed earlier, if you want to make changes in your database, you can use the update statement, which basically updates the value in a given table. And finally, we have delete. This command allows deleting specific rows from the table. Now, if you no longer want the data to be present in your table, in that case, you can use the delete statement. Now, guys, we have select statement, which also comes under DQL command, which is data query language. But in most of the cases, we consider it under DML command as well. So you need not worry. So these are the 4 statements that come under DML commands. Moving ahead, the next question is, what are aggregate functions in SQL? Aggregate function in SQL perform a calculation on multiple values and return a single value. Now, we have 5 different types of aggregate functions in SQL. The first one is count function. Count is used to basically count the total number of fields or number of data that you want from your table. Next, we have the average. Average is used to calculate the average of all the fields that are present in the table. Next, we have minimum and maximum. As the name suggests, they are used to find the maximum and minimum value while performing any complex or mathematical calculations from your table. And finally, we have sum, which is used to summarize or calculate the whole of the values that are present in the table. So these are some aggregate functions that are used in SQL. The next question is, what are constraints in SQL? Constraints are a set of rules imposed on tables of relational databases. Constraints help in maintaining the accuracy, integrity, and reliability of a database. Now we have total of 6 types of constraints that are present in SQL. The first one is unique. Unique constraint ensures that all the values in a column are different. Primary key. Primary key is a combination of a not null and unique constraint which basically uniquely identifies each row in a table. Next, we have foreign key. Foreign key uniquely identifies a row or record in another table. Next, we have default constraint. Default constraint sets a default value for a column when no value is specified. So if you're working on a database and if you haven't assigned a value into that record, it will automatically give a default value. Next, we have check constraint. Check basically ensures that all the values in a column satisfies a specific condition. And finally, we have not null. Not null ensures that a column cannot have a null value. So that was all about constraints and the different types of constraints that we use in SQL. Next question is, what are keys in SQL and why do we use them? SQL key is an attribute or set of attributes which help you to identify a unique row in a table. SQL keys are one of the most important attributes of any relational database because it plays an important role to establish a relationship between 2 or more tables. It also helps queries to execute faster, that is, retrieval of the records from the database becomes much faster by using keys. Keys also set the different constraint to uniquely identify the tuples or rows from the large data sets. Alright, now once you're asked what are keys, the interviewer might ask what are different types of keys used in SQL. So you have to be prepared for that as well. Now in general, we have 4 different types of keys present in SQL. The first one is primary key. The primary key in SQL is a single or a group of fields or columns that can uniquely identify a row in a table. For example, employee ID or a student ID in a table is considered as a primary key because it uniquely identifies each and every record present in that table. Next, we have super key. A super key is a combination of all possible attributes which can uniquely identify rows or tuples in a table. Next, we have candidate key. Candidate key can be defined as a set of 1 or more columns that can identify a record or a tuple uniquely in a table. Foreign key. A foreign key is a set of attributes in a table that refers to the primary key of another table. So if you want to connect another table using the primary key of the existing table, then the key that is present in the new table is considered as the foreign key. Now for candidate key, let's say I have different fields like, let's say, Aadhaar card, passport, or driving license as fields present in my table, so which can uniquely identify a record uniquely similar to that of primary key. Now since candidate key is a set of one or more columns, we consider all of them as candidate keys. So I hope you've understood till now what are the different types of keys used in SQL. All right. Moving ahead, let us now discuss the next question, which is what are some common clauses used with select query in SQL? Now, as we know, SQL being a query language requires a method to apply constraints on the data, and for that we use clauses. SQL clauses are basically inbuilt SQL functions which allows us to apply certain restrictions on the data in a resultant set. Now with the help of SQL clauses, we can filter the data according to our requirement, and it also reduces the complexity of a query, which helps in writing user-friendly queries which are easy to read and understand as well, which also ultimately allows us to restrict the number of outputs or the certain amount of data that we want in our resultant set. Now, let us now discuss some of the different types of clauses used in SQL. First, we have where clause. It is used to filter records in the database. Now, as you all know familiar that we have like thousands and thousands of records in our database. So if you want to filter only a particular records as per your requirement, then you can give a condition which can be done by using a where clause. Next, we have order by. Order by sorts the data either in ascending or descending order. Next, we have group by. Group by is used to group entries with identical data and can be used with aggregation functions or methods to obtain summarized database results. Next, we have having clause. Having clause basically filters the rows where aggregate values meet the specified conditions. Now, group by and having are almost similar to each other, so you can consider both of them to filter the records as per your requirement. Next, we have the limit, and again, as the name suggests, it is used to restrict the number of results from the query or the result in the resultant set. For example, if you have 100 records in your database, and if you want only 50 records to display in a resultant set, then in that case you can use the limit. And finally, we have the distinct clause, which is used to discard the rows having any duplicate values, which basically eliminates certain records that have any duplicate value. So if there are any records that are repeated in your table, then you can eliminate them by using distinct clause. So those are some of the common clauses that we use with select query. Alright, let us now discuss the next question, which is what is the difference between char and varchar data types? Now, I know you've all used both these data types extensively while working on your database, but due to how frequently we use them, many of us fail to recognize the differences when asked to choose between varchar and char in your interview questions. Now, the difference is important to know from both an interview point of view and from the standpoint of the database design as well when you're working on your database application, because a poor choice of data type from both these data types restricts the type of data you can add, which can ultimately waste space and slow down your query as well. So it is important that we understand the difference. Now, first difference between them is char is a fixed length character string data type and varchar is a variable length character string data type. And coming to char, this data type can be a single byte or a multiple byte, whereas varchar can accept character strings up to only 255 bytes. Now, character or char data type can be used when the character length is known. So if you're working or if you're specifying a column data type wherein you know the length of the character, in such case you can use the char. Whereas on the other side, varchar is a data type which is used when the character length is not clear. So for a string values, when the total number of character length is not known, in such case you have to take varchar. Now, char is used when the character length of the data is the same, whereas varchar is used when the character length of the data is changing, that is when it is variable. And finally, char is a static data type and varchar is a dynamic data type. So these are some of the main and important difference between char and varchar data types, and choosing between them is important that because it can ultimately affect your database performance. So it is important to choose the right data type. Alright, moving ahead, the next question is name few data types used in SQL. I hope you've come across this word data type in almost every programming language. So similar to those data types present in, unlike any other programming languages, we do have certain data types which are similar in SQL as well. Now, as we know, a database table must have a name and data type for each column. So when building a table, an SQL developer must decide what kind of data will be stored in each column. So the data specifies how SQL will interact with the stored data and serves as a guide for SQL engine in determining what kind of data is expected inside of each column. So we have different data types like numeric data type, which has int type, bit, float, and boolean types of elements of data types. Next, we have string data type, which contains char, varchar, and text data types. And next, we also have date time data types, which takes different elements again, which has date format, which only takes the entry of date in year, month, date. We also have date time. We also have timestamp as well. Now, other than this, we have some miscellaneous and extra data types also. For example, XML and JSON formats in order to store the data in our tables as well. So these were some of the important data types used in SQL. I hope you guys have understood. Alright, moving ahead, let us now discuss the next question, which is explain the difference between group by and order by. Now, both these clauses are one of the important clauses in SQL as they are used to filter and sort the data as per our requirement. So it is also again important that how we use them and how they're specifically being used is important. So you have to understand the differences and when to use and when not to use. Now, coming to group by is used to group the rows that have the same value, whereas order by is used to arrange the data obtained as a result of a query in a sorted form. So let's say if you want to arrange the first 10 records in ascending order, then you can use the order by clause. Whereas if you're, let's say, want to group certain columns in a particular order, so then in that case you can use group by clause. Now, group by always is used before the order by clause in the select statement, whereas order by is used after the group by clause in the select statement. So if you want to use a group by, you need to use before the order by, and similarly for order by also, it is always used after the group by. Next, group by attributes under aggregation function cannot be in group by clause, whereas attributes under aggregate functions can be in order by clause. Now, it is also mandatory to use aggregate functions in the group by. So whenever you are performing aggregate functions like count, sum, average, minimum, and maximum, in such case you need group by, whereas aggregate function is not compulsory as such to use an order by function. And finally, the important thing, group by controls the presentation of rows or tuples, whereas order by controls the presentation of columns. Alright, moving ahead, let us now discuss the next question, which is why do we use case statement in SQL? So the case statement in SQL is a way of handling the if-else statement that we use in other programming languages, which basically returns a value for the condition specified. Now, it tests a list of conditions and returns one of the multiple possible results. So it is used to fetch us a particular value based on a certain condition in your database. So the case expression basically goes through conditions and return a value when the first condition is met, just like an if then else statement. So once a condition is true, it will stop reading and return the result. If no conditions are true, it returns the value in the else clause. And if there is no else part and no conditions are true, it will basically return a null value. So that is what an SQL case statement does in your SQL database. So for example, if you consider an example here, we have a query such as select employee ID, job title, salary, and we have to mention the keyword case, and it is always followed with a when and then keyword. So I'm specifying a condition here. When salary is greater than or equals to 50,000, I want to display a string value, that is the salary is greater than 50,000. And if salary is equals to 50,000, I want to display a message as the salary is 50,000. And if both these conditions are not satisfying, then it will go to the else part, which will basically return the salary is under 50,000, and it will always end with an end as statement. So this is what case statement is in SQL and why do we use it. Alright, moving ahead, one of the most important questions, which is what are joins in SQL, and explain different types of joins. Now you might have come across the SQL joins key words in most of the cases, guys. They are one of the important statements in SQL which allows you to access information from two or more tables at once, which also keep our database normalized. Basically, normalization is allows us to keep data redundancy low so that we can decrease the amount of data anomalies in our application when we delete or update a record. We'll get into that when we talk about normalization in detail. So you just have to understand that the join clause allows us to retrieve data from two or more related tables into a meaningful resultant set. So for example, we'll understand with an example. Consider Mercedes-Benz, which is one of the largest automobile manufacturing companies in the world. So let's say they're trying to access some information of their customers. Now in their database, let us assume that they have three different tables of customer, an order table and a vehicle table. Now let's say they're trying to find a particular model type which a customer has purchased in a recent time. So for that, in order to find that data, they have to go through three different stages. That is, first they have to find the customer table, and then they have to go to order table to find the order ID so that they can get into the vehicle ID details, and finally they'll fetch the model type, or let's say the variant from the vehicle orders. Now instead of that, I'll just simply join the two tables, that is the customer table and vehicle table, based on the common column that is present in this both table, which is customer ID. So with the help of this common field, I can retrieve the model and the variant instead of searching the three tables one at a time. So simultaneously I'm able to retrieve data by using common columns in both the table. So that is one of the most important USP, or the factor that a join does when you're trying to retrieve data from more than one table. So I hope you've understood what joins are, and let us now understand the different types of joins. Now the first join is inner join. The inner join returns only those records that have matching values from both the tables, that is the left table and right table. Next we have the outer or full outer join. Now outer join basically retrieves the data from both the tables irrespective of whether they are matching or not. So it will display the values either from left table or from right table. Now next we have the left join. As the name suggests, the left join gives priority to the first table or the left table or the first table. So it will retrieve only the records that are present in the left table and only the matching records that are present from the right table. And finally we have the right join. Right join basically retrieves the data from the right table or the second table and only the matching values from the left table or the first table. So these are some different types of joins we use in SQL. If you want to learn more about SQL joins, make sure to check out our SQL joins tutorial on our channel, where we have discussed the syntax and its use cases with a certain examples and its execution in MySQL Workbench as well. So I would highly recommend you to check that out. Alright, moving ahead, next question is explain the difference between a join and a union in SQL. So now joins and unions can be used to combine data from one or more tables. Now the difference lies in how the data is combined. So in simple terms, joins combine data into new columns. If two tables are joined together, then the data from the first table is shown in one set of column alongside the second table's column in the same row. So if you look at this example where we have taken two tables, in our resultant tables, the columns are being added side by side. So each row in the result contains columns from both table A and B. Rows are created when columns from one table match columns from another. So this match is basically called the join condition. But when I speak about union combines data into new rows. In a union, each row within the result is from one table or the other. In a union, columns aren't combined to create results, but rows are combined. Unions are typically used when you have two results whose rows you want to include in the same result. That is, if you want to include the difference, the rows in your resultant set, then in that case you have to choose the union. So that was some of the main differences between the join and union statement. Alright, moving ahead, let us now discuss the next question, which is what is the difference between delete and truncate? Delete command is used to delete only specified number of rows. That is, if you want to delete only specific rows like one or more rows, you can use the delete statement. Whereas the truncate command is used to delete all the rows in a single go from a table. Delete comes under DML command, that is data manipulation language, whereas truncate is a DDL command, which is data definition language. Now, there may be a where clause in the delete command in order to filter the records. Since we are specifying deleting only specified rows, we can use a where clause to limit the number of rows that we want to delete. Whereas we do not have the option to use where clause in the truncate command, as it deletes all the rows simultaneously. Now, when you use a delete, the changes can be rolled back. So once you delete certain records from the table, you can use the rollback statement to make changes again. Whereas if you use the truncate, the changes cannot be rolled back. Once you have deleted the records from the table, it will completely just vanish from the table, and you do not have the luxury to get back to its original state. That is, it cannot be rolled back. Now, delete on a performance side, delete is slower than truncate because we are individually deleting the rows, whereas truncate is faster than delete because we are deleting all the rows at a single time. So these were some of the main differences between delete and truncate. And one thing you have to keep in mind in that when you are using truncate, you have to be careful, because if you use the truncate and once the deletion is done, you cannot get back to its original state. That is, that changes can be rolled back. So it is very important that you choose these two statements wisely. Alright, moving ahead, let us now discuss the next question, which is what are subqueries and how they're used in SQL. Now, subqueries in SQL are another important concept if you're trying to solve complex SQL queries. So in such case, subqueries can be quite handful. So you need to know what subqueries are. Now, as the statement says, as an SQL subquery is nothing but a query inside another query. And we use a subquery to fetch data from more than one table. That is, if you're retrieving data from one or more tables, we need subqueries. And a subquery is also often referred to as an inner query, while the statement containing a subquery is also called an outer query or outer select statement. We can implement subqueries with the select, insert, update, and delete statements, along with the operators like equals to, greater than, equals to, in between, and etc. Now consider an example here where I'm trying to find the listed price of all the items present in the orders table whose price is greater than the average of total listed price in that order table. So here the inner query becomes the select average listed price from the order table statement. So it basically calculates the result of this inner query first, and it passes on to the outer query. So let's say if I have the average of the listed price is 100. So the outer query basically selects the name, the listed price from the orders table whose listed price is greater than 100. So it will retrieve all the data whose price in order table is greater than 100. So in this way, you can use subqueries, to find complex or more, to find inferences of the complex queries by using a simple subquery. So I hope you understood what subqueries are. Let us now move ahead and discuss the next question, which is what is asset property in a database? Now, to ensure that the database is in a consistent state both before and after the transaction, one needs to follow certain properties, and those properties are known as asset properties. Now, where A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Now, talking about atomicity, the concept of atomicity describes how the data stays atomic. So, in other words, if an action or transaction is performed on the data, it should either be executed, completed, or not executed at all. So, changes in the data must be like a single operation. Now, next we have the consistency. Consistency, the idea behind consistency is the value must constantly be maintained. Now, the integrity of the data should be upheld in DBMS or SQL, which means the changes done to the database should always be saved. Next, we have isolation. Now, the characteristic guarantees that numerous transactions can take simultaneously without causing the database state to become inconsistent. So, transaction takes place without interruption and independently. So, changes made in one transaction are not visible to changes made in any other transaction until the change in question has been committed or not. So, isolation basically checks whether the transaction is getting successful in case of any system failures or not. And finally, we have durability. Now, durability, as the name suggests, something which a transaction done is permanent if it is durable. Durability in DBMS or SQL refers to the guarantee that data remains in the database permanently once an operation has been successfully completed. So these are the asset properties that are present in a database, which are also quite useful when you're working on SQL database, because it should satisfy the condition in the tables that you're working on. Alright, moving ahead, let us now discuss the next question. What are common table expression in SQL? Now, a CT or common table expression defines a temporary result set that a user can refer possibly multiple times within a SQL statement. So if you're someone working on large databases and if you want to use the queries that you have already created, you can just simply make a common table expression wherein it enables user to write and maintain the queries easily with increased readability and reusability. Now, CTs are more readable than subquery, which makes it an go-to SQL statement or the concept. Now, CT basically increases the performance of the query. Now, instead of writing the query each and every time while you're working on a database, you can just simply already call the common table expression that you have created earlier. Now, the syntax of CT is written as with CT name, that is, you have to mention the CT name as within the parenthesis, select column 1, column 2 from tables and close the parenthesis, and again mention the select statement, column 1, column 2 from CT name that you have written, and you can also mention the condition using the where clause. So that was all about the common table expressions in SQL. Alright, moving ahead, let us now discuss what is normalization in SQL. Again guys, normalization is a quite important concept even if you are working on a DBMS or SQL concepts. I think it is important to prepare well for your interviews, and this is one of the important question if you are preparing for that. Now, a normalization is basically the process to eliminate data redundancy and enhance data integrity in the table. So it basically is useful to have the data redundancy and inconsistency at place. It is basically a multi-step process that sets the data in a tabular form and removes the duplicated data from the relational tables. So, and also we have different types of normal forms, guys. So you need to prepare all of them, and interviewer might ask you one of the normal forms that is present. So we have 4 different types of normal forms such as 1NF, 2NF, 3NF, and BCNF. Now, a following question can be, to explain any of the normal form. Now, I'm considering here what is first normal form. So, for a table to be in first normal form, the atomicity of the table is 1. That is, every table should contain a single value and each and every record must be unique. Now, let us understand with an example here. Let's say I have a table of students which has roll number, name, age, courses as different fields. Now, as you can see, for one student, we have multiple courses present in the same record. So, we have for Harsh, he has opted for courses SQL and Java. Now, as per the first normalization definition, it is not correct because it shouldn't have multiple values present in one record or one column. So we can eliminate this by converting into a separate row. That is, we might have repeated values, but it should be unique values. So I have written SQL and Java into separate columns in a resultant table, which basically satisfies the first normal form. Alright, moving ahead, let us now discuss the next question. What is the difference between SQL and MySQL? Now, the interviewer might want to understand your in-depth knowledge, whether you're understanding the differences between a MySQL, which is a relational database, and an SQL, which is a programming language. So the difference is basically SQL is a programming language, whereas MySQL is a relational database management system which is used to perform various operations like insert, update, delete on the data that is stored in the database. So SQL is a language which is useful in querying relational database system, and again, whereas MySQL is used to store, modify, and delete data in a database in an organized way. SQL is a licensed product of Microsoft, whereas MySQL is an open source platform managed by Oracle Corporation. SQL provides adequate protection to SQL servers against intruders, Whereas MySQL being an open source platform, we cannot guarantee the security as it is unreliable. Coming to SQL, it doesn't support any connectors, whereas in MySQL we have various tools such as MySQL Workbench in order to build databases. So these are some of the major differences between the SQL and MySQL. The next question is, write an SQL query to find second highest salary from employee table. Now we all know to find the highest salary, we can simply use the max aggregate function. So the following query would be select ID employee name maximum of salary from employee. Alright, but what if you want to find second highest salary? That is where a subquery comes into picture. You need to use a subquery to first find the select maximum salary from the table, and then you have to retrieve your particular columns, that is employee name, ID or maximum salary from employee where salary is less than that maximum salary. So something which is less than the max would be the second highest, right? So that is what the logic is. And we are doing that simply with use of subqueries here. Alright, moving ahead, let us now discuss the next question, which is explain the differences between where and having clause. So where clause is used to filter the records from the table based on specific condition, whereas having clause is also used to filter record from the groups based on a specific condition. Where clause can be used without group by clause and having clause cannot be used without group by clause. Where clause implements in a row operation, whereas having clause implements in column operations. Now in general, where clause cannot contain aggregate function, whereas in having clause you can include various aggregate functions like count, sum, average, minimum, maximum, etc. And finally, where clause can be used with select, update, delete statement, while you cannot use any of this statement with having clause, where you can just only use the select statement. So that were the differences between where and having clause. The next question is, write an SQL query to return even and odd number records from table. Now, I hope you guys know the logic behind this. It is a simple SQL query. You just have to use the modulus operator, which returns the records with odd or even values. For that, we need to check the remainder when we divide the column value by 2. So when the remainder is 0, that is basically an even number. Otherwise, it's an odd number. So the query for even number records is select star from table where ID modulus 2 is equals to 0. And for odd number records, you need to write a query as select star from table where ID modulus 2 not equals to 0. Alright, the next question is, what is the difference between a function and procedure? Functions and stored procedure are another important concept, but their way of implementation is a bit of similar. So, but you need to understand the differences on how they work. So function basically returns a value. That is, it should always return a value when you're performing a complex function on your database table. And function can be called from a select query as well. And function is generally used to perform some calculation and always return a result. Whereas on the other hand, stored procedures cannot be used in SQL statements anywhere in the where, having or select clause. Procedures can either return a single, multiple or no values at all. That is, we have an optional condition here that procedure may or may not return values in the resultant set. Now, using stored procedure, we can prepare SQL code which you can save so that the code can be reused again and again, which is not with the case of function. So stored procedure can be quite helpful again if you're working on large data set and if you want to retrieve values and if you want to fetch data. In that case, stored procedure can be quite useful as you cannot, as you can use it simultaneously or multiple times. Alright, moving ahead, let us now discuss the next question, which is how to create a new table from an existing table. Now, creating a new table from an already created table is a bit of easy. You just have to use the create and select statement. So as it states, a copy of a table can be created from an existing table using the combination of both create and select statement. And the syntax is create table, mention the new table name as, mention the select statement inside the columns that you want to retrieve from the already present table, that is from the existing table, and you can also mention the where. Now if you want only a particular column, in that case you can use the where condition. So that is how you can create a new table from an existing table. Again, this is a simple SQL query wherein the interviewer wants to know if you're having proper knowledge on the tables, like of creating a tables. All right, the next question is, how is SQL different from NoSQL? Now, you guys might have heard about NoSQL, which is basically trending a lot nowadays, where it is used to store a lot of unstructured data. Now, as the data is increasing day by day, SQL has been in a downside where it is unable to store, a lot of unstructured data that is coming from the internet and from the, World Wide Web. So, in that case, companies have switched to another technology which uses a new way of storing the data, be it unstructured or semi-structured data, which is NoSQL. However, there are differences between SQL and NoSQL. That is, SQL is a relational database. That is, it comprises of rows and columns in a table, and it is only stored in that format, while NoSQL is a non-relational database, which basically stores data in a key value pair or a document based or a graph based structured. And while SQL has a fixed schema design and structure, that is, you need to give the table structure, that is, you need to predefine the schema, that is your rows or your columns in hindsight, whereas NoSQL has a dynamic schema design and structure, that is, you need not provide a schema if you're working on NoSQL database. SQL handles complex queries, whereas NoSQL handles large volumes of data. So let's say if you have some data present in your table, and if you're constantly working on it and performing complex queries, in that case you need SQL to retrieve the data. Whereas if you're having large volumes of data, in that case you can use NoSQL. SQL is vertically scalable while NoSQL is horizontally scalable. Now, from what do I mean? Scalable is basically as a term used in database, whereas scalability is the ability to expand or contract the capacity of system resources in order to support the ever-changing usage of your applications. Now, when I talk about vertical scaling, it refers to increasing the processing power of a single server or cluster. Now, both relational as well as the non-relational database can scale up, but eventually there will be a limit in terms of maximum processing power and throughput. Whereas the horizontal scaling, also known as the scale-out method, refers to bringing on additional nodes to start the ring. That is, you can even add CPUs and RAMs to your existing server. Now, this is difficult with relational databases because due to difficulty in spreading out related data across the nodes, but with non-relational database or with SQL, this is made simpler since collections which we use in NoSQL are self-contained and are coupled relationally. And finally, SQL follows asset property that we have already discussed in our previous question, which is what is asset property, and whereas NoSQL follows cap property. So these were some of the main difference between the traditional SQL language and the new or the emerging technology that is NoSQL. Alright, moving ahead, the next question is, write an SQL query to find the nth highest salary from a table. Now, if you're a beginner or someone working as an SQL developer, even to an intermediate level, finding first, second, third highest salary can be quite easy, using subqueries or functions. But whereas to find the nth highest salary, you need a bit of more of assistance. So using a subquery, you can find the nth highest salary, wherein the query is written as select salary from employees as employee 1, where n minus 1. Now here n basically denotes the nth highest salary that you want to calculate. Let's say if I want to find the 35th highest salary, you need to mention 35 in the n place, equals to select count distinct salary from employees as employee 2. I'm giving an alias name here, where employee 2 dot salary is greater than employee 1 dot salary. Now, the logic behind this is I'm basically self-joining the same table again, and I'm comparing the two tables, wherein it will compare the salary from the second table, which is greater than the first salary, and it will retrieve the data in the resultant set. Now you can use this or do this in another way using the limit clause. The query is written as select star from employees where salary is equals to select distinct salary from employees order by salary limit n comma 1. Now this is applicable in most of the databases that you're working on like MySQL, SQL Server or even Oracle as well, where you just have to specify the n value and use a limit clause and it will do the rest. So let's say if I want to find 50th highest salary, in place of n I can basically put 50 also. And we can also find the nth highest salary using the row number function. Now if you want to know in detail on how to use the row number function and the syntax of it, you can check out our video on how to find nth highest salary from a table in our channel, where we have discussed clearly on how to use various different methods and especially how to use the row number function as well. So I'd highly recommend you guys to check that out. Alright, moving ahead, the next question is name the operator which is used for pattern matching in SQL. Now SQL like command or operator is used to find a specific character in a database. So it basically determines whether a specific character that you're mentioning matches a pattern string or not. Now this is used to perform complex pattern search in data wherein you don't know the complete information that you're working on the data. So just with the help of some certain specifics or specific characters that I'm talking here about, you can basically retrieve the data. The syntax is followed as select column 1, column 2, column n from table name where column name like pattern. Let us just understand this an example where again you can have a follow-up question for this, where it is where the interviewer can ask you write an SQL query to fetch the employees whose name begins with any two characters followed by a text RA, which is basically two characters, and ends with any sequence of characters. Now in general we have two different like operators, which is underscore and percentage wildcard characters, where underscore matches a single character and percentage matches 0 or multiple characters. So the answer to this query is basically select employee name from employees where employee name like within the parenthesis. Now as the question is stated as it should begin with any two characters. So I can basically put an underscore here for the first two places followed by a text which is RA, and it can end with any number of characters. So let's say if I have Murali whose name starts with M and the next character is U. So you can take it as MURA and it can end with any characters, again LI. So Murali is an example for this, or else you can take Surat. Again you can have two different characters at the first position and it can end with any number of characters at the end. So this is how you can use like operator in order to fetch certain patterns when you're not aware of the string or the data that you are trying to retrieve from the database table. Alright, moving ahead, let us now discuss the next question, which is explain what is an alias in SQL and why we use it. Now I'm sure you know what the term alias is. It is giving a temporary name to someone. So similarly in SQL also, it is basically a temporary name that is given to a table or a column while writing a query. Now alias can be quite useful because let's say if you're working on a database and if the columns or the table names are so long, now you have to write or type the database table again and again in such long format. So instead of that, I can simply write a alias name for that. Now let's say I have employee details as my table name. Now instead of writing every time employee details, I can just give another alias name like EMP or EMP details. So giving aliases makes the table or column name more readable as well. Now if you're using alias, it is a temporary change, guys. So it is just limited to the runtime of the query wherein you are executing a query. So it will just give alias name for only that moment and it is not permanently saved. So if you're performing for column operations, the alias can be used as select column name as alias name from table. And if you are giving an alias name for table, you can write a select column 1 or column so on up to n columns from table name as alias name. Alright, let us now discuss the next question, which is explain views in SQL. Now, a database view in SQL is like having virtual tables containing a single query and its result. Now, the result is usually a virtual table which is having the same amount of rows and columns just like the actual table. So, we can either pass a query to store all the rows and columns of a table or just a part of it. Now, the most significant advantage of using a view in SQL is that it also stores the query, and hence we don't have to write it again and again from the scratch. But again, then the question arises, why not use a stored procedure instead? Now, even the stored procedures can hold a query and execute whenever called. However, the advantage with views is that they're easier and more straightforward compared to procedure. And the query is written as create view name as select column 1, column 2, up to so on, column n. From, you can write a single table or from multiple tables as well. You also use a where condition. So we can just easily create a view in SQL from a single table or even multiple tables using the create view statement. But before anything else, we need to already have a table so that we can create a view for it. So that was views in SQL and how they are used. Alright, the next question is, what are triggers in SQL? So a trigger is basically a stored procedure, which is a set of SQL statements saved under a name, just like a function, or even when you're writing, views, which takes a temporary name so that it can be reused. That is, triggers can be executed that are automatically, called on when there is any change in the database. Now, for instance, you may program a trigger to execute when data is inserted in a table. Now we have different types of triggers as well based on the event and the timing of it. So we have different DML triggers, we have DDL triggers and database triggers. So now in DML we have insert, update and delete. And in DDL triggers we can use create and alter statements. Now the timing is also important when you're triggering certain event. That is, you can use before trigger. That is, you can use before insert trigger. That is, whenever you're trying to insert a new record, if it is not satisfying the condition that you have specified, then it will omit. So it basically backfires before the specified event has occurred. Similarly, you can use after trigger as well, which basically fires after a specified event has already occurred. So that was triggers in SQL. So an immediate following question would be why we use SQL triggers. Being an advanced level concept, the interviewer might want to know the in-depth knowledge of what SQL triggers are. So SQL triggers allows the user to avoid redundant code with multiple programs need to perform the same database operations. It also maintains complex column constraints and inferential data integrity, and also it prevents invalid transactions and makes sure that the user that is authenticating a transaction is being successfully executed. And finally, it increases the performance of the SQL queries because it does not need to compile each and every time when the query is getting executed. So those were some of the main reasons why we use SQL triggers. Alright, moving ahead, let us now discuss the next question, which is what is indexing in SQL? Now, indexing in SQL is a special table used to speed up the searching process of the data in a database table. Now, let's say if you're working on thousands and thousands of records, it becomes quite difficult, if you try to retrieve certain data, which ultimately impacts the performance of the query. Now, let's take an example here. Now, you all might have, done this in your school days, wherein you have this textbooks, and in textbooks you have table of contents. Now, if you want to refer to a particular chapter, instead of searching from page 1 and simultaneously moving on to the next pages, you can just check the index page where you can find the number. Now, let's say in the example, I want to find the concepts of the neuroscience of hospitality, which has an index 62. So instead of searching from the start, I can just turn on to the 62nd page and just refer to the contents that are present in that chapter. So similarly in SQL as well, instead of searching, the whole table, you can just speed up the process by using an index. So the main benefit of using indexing is it improves query speed as discussed, and faster data recovery is also another factor while using indexing. And also the efficiency, that is the search efficiency of the query increases, wherein the performance of the database ultimately impacts on how you're running the query. Now the more complex the queries, the more performance it takes, which ultimately impacts the efficiency. So if you're trying to perform data operations on more than 1,000 records, or let's say 1 lakh records in a table, in that case you can use index. And that brings us to the final question, guys, which is, what are the applications of SQL in real life? Nowadays SQL has been in a tremendous usage for more than many sectors in real life as well. For example, if you take banking sector is an important criteria for our nation, for its development. So banking uses SQL, and it is one of the major components in banking sector, where bank stores the account details of customers and the transactions done in the database on a regular basis. It is also used in education sectors like schools and universities, where the users or the people in authorization use SQL and databases to store and retrieve information about their students, faculty, and staff information. Next, we have finance. Finance is another massive area where SQL queries are used regularly in managing the assets, revenue details, shares of the companies. Now, faster execution and retrieval of data plays an important role for all the businesses around the world to make strategies and derive insights from it. And for that, we need SQL to retrieve the data as early as possible. And next, we have healthcare. Again, hospitals and other medical centers use SQL to store the details of the patients without any hassle. It also helps in maintaining all the documents, necessary bills, as well, etc. Manufacturing is another important sector where SQL is used, and considering the vast presence in the market, manufacturing also uses SQL in order to find the data from the machinery, the employees that are working in a particular manufacturing plant, and etc. It is also widely used in travel also, in order to store the details of the customers. Let's say if they have any offers to be presented in real time, we use SQL in order to store all of this in no time. And finally, we have e-commerce as well. Now, companies like Amazon, Flipkart, considering its vast presence in the market, retail and e-commerce company stores its customer data to improve their shopping experience by providing special offers, which in turn helps the business to grow. So these are some of the applications of SQL in real life.
So here we wrap up with SQL full course. If you have any queries, feel free to add it in the comment section and our experts will feel happy to answer. If you like this video, do subscribe to Simplilearn and hit the bell icon to never miss any updates from us. Thanks for watching this video.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.